we go. This is stream number 9 of making my own keyboard and using Rust firmware. And I am going to try to attempt to fix the bug that I had while working on stream number 8, trying to get one of these controllers to program the other one. I realized a mistake that I made, a big one. So basically in this programming state, we're forwarding the program from the primary board to the secondary board. I forgot that as it's being received by the secondary keyboard, it will go and actually erase a sector flash and program it every 4 kilobytes that it receives. So I realized, well, what happens while we're erasing a sector and reprogramming it while we're still receiving bytes over the UART from the primary controller? The answer is that the FIFO is going to overflow. So it explains why we weren't getting nearly enough bytes received. I need to make sure that the primary controller here, when it's sending the program to the secondary board, only sends a sector at a time, and between sectors waits an appropriate amount of time to make sure that the secondary controller is ready to receive the next sector. If I wanted a really nice, clean design, I could have a two-way communication, have the secondary controller tell the primary one, hey, I'm ready for the next sector. But I'm just going to cheat, I think, tonight, and only have it be a one-way communication. We'll just have the primary controller, it'll know when the secondary controller will be programming the sector, and it will just wait the amount of time that we've estimated before it takes to actually program a sector. So let me see. It's been a week since I worked on this project, so I need to refamiliarize myself with where we actually do the programming. It's not in this USB block, right? Oh, wait. This is when we're idling. I think I meant to move this to another function, but I haven't gotten around to it. Yeah, here it is. Here's the secondary controller, right? We process serial input here. And it goes to this next state. And if it's receiving a program, right, and we get the sector, we program the sector, right? So during this call, we're going to be receiving more and more bytes, and they're just going to overflow our FIFO. Hey there, Syrian. How are you today? So yeah, I realized the mistake that I made. I don't know if you heard me, Syrian, because I sort of got right into the explanation when I started the stream, but while the secondary controller is running this function, our FIFO is going to overflow because it takes more than 32 bytes of receive time to actually program a sector. Okay, that's an interesting name. I'll just say Blue. How am I going? Pretty well. How are you doing? And I'm doing well, thanks, Sarian. If I remember correctly, in the flash.rs, I put something in here to wait. Here it is. 100,000 microseconds per sector. Yeah, I mentioned it in the Discord. So I think what I'm going to do is have there be a timer for 100,000 microseconds or 100 milliseconds, during which time we're going to pause transmitting to the secondary controller. Okay. A reference to the U.S. Democratic Party. All right, I think I'm going... Oh, what's this? All right, never mind. I think I'm going to add a state into our state machine here. Right now we're in one state called forwarding program. I think after we've sent a sector, we should go into a state where we pause for a while. We'll say pause between sectors. We're not going to need a prefix anymore. We need to hold on to the offset and size, so I guess I will just have a structure for this state. Okay, pause between sectors. So I'm gonna hit Control Dot, fill match arms to get this new state here. All right. This is what do we do if we receive input from this state? So I think I'm just going to have it do the same little thing to forwarding program. So pause between sectors, right? And then we'll just repeat this there. Okay, and then down here we need a new match arm, right? This one is for what? When we process serial input? I thought that's the one I just did. Oh. It's similar. That's the state machine move. This is after we move the state machine. Oh, right. This is controlling the color that we make the LED. So I could choose to change the color of the LED. I mean, I guess we could do that. I could have it alternate between one color and the next. Yes, Ariane, we could have two-way communication. I think that would be a cleaner design, but it would take more work. So right now I'm just going to cheat and have the primary controller just pause. So it'll account for the time the secondary controller will need to erase and program a sector before moving on. But yeah, a better design, a little bit more work would be to actually have two-way communication. Have the secondary controller say, "Hey, I'm done with that sector. Send me the next one." And this guy can say, "Okay, going to the next sector." I'm just going to leave this empty for now. I need to think about what color the LED is in each state. Okay, I've already thought about it. It's easy. When we enter the receiving program state, we turn it white, right? And then when we enter the forwarding program... Hold on. This is the receiving. Never mind. The receiving. Oh, right. We go from receiving to forwarding once we've gotten the whole program, right? So it stays... Did I tell it to stay white? I'm gonna have to... I think I'm gonna have to search for this. I thought I had to turn a different color when it goes into the next state. Okay. Is it all in this function process serial input? Oh, it's purple if we're the primary controller. It's red if we're not. Why did I do it this way? Let's look. What does next do when it goes to commit? Actually, easier. I could just search for commit here. Find all references to commit. There it is. If we're the primary controller, then we go to the forwarding program stage. For the secondary controller, we just flash commit to reprogram. Right, I had this hacked for now. I'm going to remove this hack. Hey there, Master Agent Miyazaki. You didn't miss any streams between. I was on travel for a week, and I couldn't stream. I was in a place that had internet, but just barely internet. I did bring my keyboards, but I didn't actually do any work on them. I brought them in case I might have a good enough internet connection to work on them in stream, but turned out I didn't. I need to find, here it is. I need to find this. Delete the comments, delete that. Okay. Okay, so it goes into the commit state briefly if it's a primary controller, but it'll go immediately to the forwarding program state. Okay, and this is in the idle loop. Whereas, what was it? This is when we receive input. Okay, we're not going to receive any more input. That's the thing. We're not going to receive any more input as the primary controller once we've gotten to this commit state. So it'll stay white. I thought it changed again though. See how much I forget in a week? Oh, okay. Here we go. I do have it changed to red when it's going to reprogram. Okay, that's what I was forgetting. That's what I was missing. Okay. All right, I need to find the place where we're forwarding the program and it reaches a sector boundary. That would be here, right? The prefix is empty. This is the bytes left to send. Get a slice to it and then try to write it. That's the thing, right? We don't want it to try to write the entire program here. I want it to write just the next sector. Okay, so then this should be like the minimum of... I know, instead of forwarding program.size, I need to find the next sector boundary. So I could take the offset modulo sector size and then add a sector size, and then that's the next sector boundary, right? Next, oops. Next sector boundary equals this modulo. Do I have a constant for sector size? I do. Last days have been a pain in the end. Spent the last 2 to 3 days writing documentation, writing Doxygen comments. Ooh. Sorry, Master Agent Miyazaki. Hey there, Gadam. How are you doing? Hey, check out my keyboard. It's got 2 keys on it. The Q key and the W key. Working today to get this controller, which is going to be like on the left-hand side of a split keyboard, when it gets programmed, to forward the program over these, I think it's this yellow wire or the green wire, one of the two, to the secondary controller, which is going to be on the right-hand side. Almost got it working a week ago and failed to understand the problem I was running into, and then after the stream, I realized what it was, and I'm like, okay, I'll just wait till the next stream to do that. Is this logic sound that we modulo the sector size, so that'll tell us, that'll give us the address of the first byte of the sector we're in right now. Add sector size, so that gives us the first byte of the next sector. And then I kind of want to get the lesser of that, and the size of the program is however many bytes we're going to send. I think that's what I want to do. So bytes to send is minimum of 40 program size and next sector boundary. Do you prefer Rust over C++? I actually do. There are a lot of things I like about Rust that aren't in C++, such as built-in package management. Dependency system is wonderful. So the fact that you can just do that, you just add one line here, and when next time you build, it automatically downloads and builds it and links it. I don't have to mess with the build system. It's really nice. Keep you track of which sector you're in. I think we're going to be doing that with just this is all we need to do to keep track of what sector we're in. Because the sending program, all it really needs to do is make sure it only sends up to the next sector boundary, and then we'll have to have a check, like if we just sent all the bytes for a sector, then we better go into that wait loop before we send the next byte. Otherwise, we risk it being dropped out of the FIFO of the receiver of the secondary one. The keyboard project got you interested in picking up a personal project? Oh, neat. It's not a keyboard, but it's a tiny OLED display screen on a microcontroller. Oh, neat. So when I'm done with this bug fixing today, the next thing I wanted to do was get into the PCB design. While I was on travel last week, and when I had free time, I actually watched YouTube videos on KiCad, or KiCad. I don't know how, some people say KiCad, some people say KiCad, but open source PCB CAD suite. So I'm going to get into that. I want to design not the full keyboard, but some kind of intermediate step, just to a trial run. Yeah, I'll be doing it on stream. So I have it all installed. I'll probably just start working on the symbols, and then maybe the schematic for just a scaled down keyboard, maybe a 2x3, I was thinking, because that way I don't need to buy any more parts. I have all the parts I need, except for the TRS cable and connectors. I need to buy those, but I have everything else here. I have like 20 of these switches, like 10 of the whites and 10 of the browns. I think I have 20 of the sockets, but maybe I only have 10. I might have to buy more sockets. And I don't really need much else other than connectors and a cable. Anyway, this is going to stop at a sector boundary. So after we write it, if we advance to a sector boundary, we'll need to go into another state, right? I think it's here we want to make this determination, I think. I think we just take the offset and check if we're at a sector boundary, right? What if we tried to write something and we were at a sector boundary before and we wrote 0? What happens? Could leftovers be 0? I don't know. Okay. KiCad? I think it makes more sense since it's a keyboard. We'll say KiCad. Tomato, tomato, exactly. It's however you want to pronounce it. I probably should look at this one and see, does it ever write 0? Okay, so if 0 bytes were written, a different thing is returned. So it'll always write something if it gets into this OK result. So then I should just have an else here where it couldn't write anything, so it should just do that, right? And then we'll move this into here and say basically if we're at a sector boundary. So if the offset modulo sector size. Try to do this without using the mouse. I need to practice my what do you call them? Arrow, page up, page down keys on this keyboard. Equals is which button? This one? Else? Still pretty incompetent as far as this keyboard and coding, but that's okay, right? So we're gonna do a pause here if we're at a sector boundary. And I need to assemble the pause between sectors here, right? It's going to be assembled from the size and offset, which we get from the forwarding program, size and offset. Okay. Size, offset. Cool. In that state, I need it to start a timer. Oh, why don't I just put the timer in there? Wouldn't that make more sense than anything else? Maybe not, but I'm gonna do it anyway. What is the type of this timer? It's just countdown, okay. So why don't I just put one in there? Countdown. It's gonna have a borrow though, right? Do I want to start adding lifetimes to this state? I don't think I'm going to do that. Instead, I think what I'll do is just keep it local to this run loop. Here, we'll have it here. Set up a timer to be used when programming, when forwarding new flash programming to the secondary controller in order to wait sufficient time between sectors. I'll let roulette mute sector programming timer. Just copy this right here. Okay. And we want to do this start at that point down here where we're about to go into that state. Start. And the count, we ought to make this a constant, right? Let's put it a constant up here. This is a conservative estimate of how much time is needed. It's really how many microseconds, right? How many microseconds are needed to erase and program a single four kilohertz sector of flash. Let's call it sector programming. Whoops. Max. I'll say call it max sector programming time, or time microseconds. And that's just 100,000. Need to give it a type. U32, I think, is the what type we've been using for that. Okay, let's search for 100,000. We'll find it really quick. Nope, maybe not. I gotta type it up here, I think. There it is. It's when we set up the watchdog. So I'll just paste it there. Hello, Prutz1311, how are you today? Alright, so I'm going to use it here now. I think start needs me to turn that number into microsecond, a time type, right? Where do we do that? Yeah, by calling this microseconds method. I need to import that. Alright, so officially need to clean up this code because there's too much indentation. You're dealing with some kind of flash memory device, and it's a flash memory chip. Do I have a little pencil I can point at it? Yes, I do. I'll use these tweezers right here. So it's this little chip right there. I should hold it up to the camera so you can see it. Hold on. I got a little cable tangle going on here. How did that happen? Ah, there we go. All right. This chip here is the microcontroller. Right there, right? This little guy over on the left is the flash. So he holds about 2 megabytes of programming. I didn't touch it. Don't worry, Sarianne. Maybe next time I'll use a plastic tip just in case. So yeah, the microcontroller we're using is the RP2040 made by Raspberry Pi. So I don't remember the manufacturer of the flash chip, but it's really teeny tiny. And they're connected together with a 4-bit wide serial port of some kind. Yeah, the controller is bigger than the memory. Flash chips are really small these days. I mean, if it's only 2 megabytes, that's teeny tiny in 2020. Okay, I need to have it actually check that timer in that state. So where are we going to do that? I guess we're doing it here, right? Handle the programming state transition from delay before commit to commit. Wait a minute. What does that mean? Pass Raimu. Why did you write that? From delay. Handle the programming state transition from delay before commit to commit. Oh, okay. This is out of date then. Because it really only originally handled this state, right? Now we have the forwarding state. Yeah, okay, that's why. So really this should be... What? What are we doing here? Perform the next step. If any. Actually, that's a bad way to describe it. I'll get back to that later. But I need to add that state. Because we'll be checking the timer, and if it's expired, then we'll go back to the forwarding state, right? Equals greater than block, comma. Okay, now how do I check the timers? It was with some method. It was called wait. Yeah, really, unfortunately, named function because we're not actually waiting. We're checking to see if it's, we're actually polling it. Yeah. So this guy, sector programming timer, we'll match on that. On its weight, right? Fill match arms. I guess was this, why do I handle that? Weight doesn't return anything but that. Whoa. What happened to my window? Okay. I hit a wrong key and my window went crazy. I'm trying to hit my hotkey, but it's not working. What did I do? Hold on. Ah. Sorry, I hit the wrong key, and now my macro's not working. Why is it not working? I don't know. My auto hotkey script is not working. Or I'm not hitting the right combo or something. Anyway, let me get back. Let me see if there's anything in chat. Does go in USB drives or into SD cards? I don't know. I'm not sure about what a USB drive or SD card would have, but the package that this flashes in has other things in it, like serial bus I mentioned. I don't think an SD card or USB drive would have that, but I'm not sure. Regarding the hardware timers, you're pulling the time left for an iteration or using interrupts, or maybe both. We could be using interrupts, but right now we're not. We have nothing better to do than to poll. An interrupt would be valuable if we had other work and we wanted to use an interrupt to avoid polling, I guess. But right now we have nothing better to do, so it's easier to just poll. I've had quite easy polling timers in your TNC 4.1, but I need to end the timer around 5 to 10 cycles before. And it is not consistent enough for some things you want to do. You mean like that you want to hit a time interval very precisely, and you want to like have it wake up or pull right before it happens, something like that? Interrupt causes it to break. You're experiencing similar crash to the one I was experiencing, and also working on a flash chip. Maybe you should see something similar. So for my problem, it wasn't that it was crashing, it was that it was losing data and I couldn't figure out why. And the answer is losing data because while it was reprogramming, it was still receiving the next sector and it was overflowing its FIFO. The VS Code plugin? No, it's on my auto hotkey script. Unless I'm just going nuts and I'm hitting the wrong key thing. Which I might be. No, that's not it. I have an auto hotkey script that centers this, that positions this window just perfectly, and it's not working right now. Okay, well I'm just going to manually do it, just based off of what my camera's showing me. There, that's good enough. And I'll just do it for the next one too. I don't know what I'm doing wrong. Oh, my Alt key got swapped somehow. Maybe that's what it was. Okay, anyway, back to work. Okay. I wanted to see the implementation of this. Here's where I was looking at. Yeah, so it only returns okay or would block. So there really is no point in having that panic down here. What if I just say it's unreachable? Because I know it is, right? And then I can make make it also unreachable. So we don't care about that, right? It's also unreachable here. And then we'll just handle the would block case explicitly. All right. Okay, there is no value there. Error is a would block. Would block, we do nothing. And then okay means that we need to go to the next state. Okay, so then I do need to repeat this here, actually. This has to yield a value. This one, though, goes here. And I need to fill this one in again. Prefix can be an empty vector, right? This will just be pause between sectors. And dot, this one's size, and this one's offset. USB stands for Universal Serial Bus, yes. Do those controllers usually perform things like wear leveling? Well, there are two things in a USB drive, right? They say USB drive because its interface to a host is through the USB Universal Serial Bus. But then the actual storage and flash or whatever, that really has nothing to do with USB. And yes, I think the controller inside of the USB memory card usually does things like wear leveling, where they'll just cycle through the flash and use all the sectors before erasing some of the earlier ones. I think they all do that. But now you need it for sending bytes for the startup sequences for some of your small displays. With the polling, it's been too inconsistent. Yeah, and I'm not going to rewrite my flash devices that frequently either. Just every time I update the program, which I think will just be in the hundreds or thousands of times. And it has, what, 100,000 cycle lifetime? Okay. I think this is correct. Let me do a once over. Let's just build it. Make sure I didn't miss anything. Does the controller keep the data on how many times each sector is written to? It might. Mine does not. But if you're talking about the controller, are we talking about the USB, a USB drive like you were mentioning before, or are you talking about mine? Mine, I was keeping track of the number of times I was rewriting the program, but I stopped doing that. Because I was only doing that as an experiment. I actually don't really care how many times I write a consumer storage device probably does, because I'd expect that. Well, actually, maybe they don't. Why would they need to have the counter? Maybe to warn you that, hey, this drive is getting old. But I don't know if any drive that actually does that. I would guess that a consumer storage device would just remember, or just have some way of tracking the sectors it's erased and written to, and it would just always prefer to program the unused sectors first and cycle through the whole flash chip, and then it would just start over. So I don't think it really care how many times each sector is written. It would just care about which sectors it hasn't gotten around to programming since the last erase. I think it's probably the only thing that those things track. Okay, let me review this again. So, and I do need to refactor this. If we're in the forwarding program state, the prefix is empty. Yeah, we definitely need to refactor this. We compute the next sector boundary. So it's our current offset. modulo the sector size plus one more sector size. Then we say the bytes left to send is the minimum of all the way to the end of the program or the next sector boundary, that minus the current offset. So then we get a slice to that, and then we try to write that. And if we are able to write something, then we advance our offset. If we get to the end of the program, we ourselves commit our program, right? Otherwise, we check, I guess this could be an else if, because this never returns, right? Shouldn't this be an else if? Else if we're at a sector boundary, then we start the sector programming timer, and we go into the pause between sector state. So the next loop will go into the pause between sector state, and we'll pull the timer. If it's gotten to the end of the interval we're waiting for, we'll go back into the forwarding program state, and we preserve the size and offset. We don't need the prefix anymore. If we're not at the end of the time to wait, we just remain in that state. And it's not possible to reach. Okay, I think this is good enough to try. So, if I remember correctly, I can use my own reprogramming code, but I can only do it when the other one's not connected. So let me power it off like that. Yeah, and we'll just run it program. So it's trying to reprogram the secondary controller, but secondary controller is not even powered on, so it won't be able to do it. That's weird. Is it still going? Is it dead? Okay, I forget the state I left this thing in, so we're just going to reset it and flash it the other way, the old way.
No.
Which pin? This one. Okay. Apply the power to the correct pin. Don't destroy your device. Flash. There we go. Okay, now let's try again. Interesting. I think it's stuck. I think I need to have it print out more stuff about what it's doing. Yeah, it's stuck, and it's showing purple. Let's catch up on chat for a second. Tracking back sectors is really all you can think of for important data. Yeah, if like something fails, it'll say, I don't want to use that sector ever again, so put it on my list of things never to touch. How is Rust doing for interfacing hardware directly compared to C? You have to do a little bit more stuff for that. Like, where did I have an example of that? Right, like this. So I'm basically having to go to a library function to say, give me a slice into memory. Here is the address. And then I have to do this type conversion to a constant pointer to bytes. And then I'm associating a length with it because I'm getting a slice, which is like a fat pointer. So there's the concept of fat pointer with the pointer and the length, and the fact that I have to call a library function to assemble that fat pointer, and then this typecast to a pointer. There's a little bit more overhead, I think, in terms of like my understanding or programmers' understanding of what you'd have to type here. In C, you could do this a lot more concisely. Yeah, we have to say it's unsafe because what if I miscalculated the address, right? I might now trash my heap or something. Yeah, fat pointer. Let's look it up. Fat pointer. Rust. Or do they say fat? Yes, they say... this isn't introducing fat pointer, though. We need to have the introduction to it. I was hoping that one of the top hits would be the Rust book, but I guess a Stack Overflow answer is as good as any. The term fat pointer is used to refer to references and raw pointers to dynamically sized types. It contains a pointer plus some information that makes it complete, e.g. the length. So a regular pointer is just an address. A fat pointer is an address plus a length, or sometimes it's an address plus some other information that binds it to a certain type, right? Like a vtable. A pointer to the object and a pointer to the vtable is another kind of fat pointer. So they go into like the slice is the one I was talking about first, where it's a pointer and a length, and then there's a trait object, which is like C++ object where you have pointer to where it is in memory and a pointer to its vtable. Actually, I don't know if objects in C++ are laid out like that. It's been a while since I looked into the internals of C++, but you get the idea. It's it's a pointer plus some metadata. Are you converting C things into Rust thing, and then you have to use unsafe? You have to do unsafe whenever you need to give your code the stamp of programmer approval to the compiler. Otherwise, the compiler says, I can't compile this because I can't guarantee that it's safe. C++ is calling you back home. Yeah. C++ embeds the vtable in the object itself. Is that how it works? So... yeah, that's right. There's like what they call a thunk in there, right? The pointer to the object actually points to the vtable, or you can go from the first byte of the object like back and find the vtable or something like that. But yeah, this is very important, this keyword here. This is saying that everything inside of here, the compiler cannot guarantee is safe. So it's up to the programmer to ensure that this is safe. Otherwise, we take on the responsibility that if it crashes, it's not the compiler's fault. It's our fault because we said that this code was not safe. All right, I was going to find out where the LEDs turned purple again. Here, right? Okay, yeah. It's when we go to reprogram the secondary board. So we're crashing somewhere, I think, in there. Find references to commit. I probably screwed this up at some point, right? Go into the forwarding program state. Is that size correct? Hopefully that size is correct. We should like print something, shouldn't we? Yeah, let's just sanity check here. We'll do a diagnostic log message. Forwarding program bytes. And I'm going to put something in, where is it? Here? We know that it turns red when it's done, but we don't have anything here when we're starting the timer. So we'll say, sector sent. Waiting a bit. Okay, we'll just take this offset, right? Minus the sector size, I guess. And let's have it do an info when we get to here. Sending next sector. Oh, I can't do it like that. I have to put a bracket there. Move this bracket down to there. Like that. Alright, build it. Let's reset this guy. Alright. Flash. And let's try programming again. Okay, it printed the forwarding one. And we're getting that back out from the peer. But it stops there for some reason. We never got to sending next sector. It's like it's in some kind of infinite loop. So you're uploading the software to the controller? Yeah, so through this cable on the upper left here, it's going to my computer, and this program here, I won't show the whole program, but we connect to the serial port. Serial port is implemented by our device, right? So it's both a serial port and a keyboard. And so when we connect to it, we'll write all of our buffer. Oh, sorry, look at the wrong lines. Our send buffer. We're going to try to send all of our send buffer, right? And until it's all gone. And we set up the send buffer where if I didn't tell it to program anything, it's nothing that we're sending. But if we told it to program, we're sending the line program character turn line feed, and then the size of the program in bytes right here. Yeah, pushing that byte by byte, big endian, and then appending the program to that. And so that's being sent over the serial port over USB to my primary controller, and then that is using the UART, which is these two wires, to go to the second board, which is also serial port. So serial port over USB, and then actual UART serial port there. Are you read logs from the controller like this info? Well, the serial port is bidirectional, so that's this part here. Once we've connected, we're going to read the serial port, and if we have anything from the controller, we will write it out to standard out. And back on the embedded side, it's harder to show that, but that code is around here somewhere. Main event loop. It's here in poll USB. Yeah, if we have any data to write. Where is it? This one. So there's this host serial buffer, which is a ring buffer, right? So there's a corresponding host serial buffer writer. Actually, I know where that is. That's in my main program. Oh, no, it's not. I moved it to keyboard. Buffer writer. Did I not call it writer? I'm getting lost on my own code. It's in new, I think. Yeah, so here's where we can configure serial port between controllers. Here's where I set up the USB bus, and here's where we have the serial port over the USB bus. Here's the ring buffer that I set up to write to the serial over USB bus, and then we give the writer to our logger, and what our logger does is it stashes the writer here, and then whenever a log message is made, we push into that ring buffer this formatted message, and then like I showed back a ways, is it here? No. It's right here. This is where we peek that ring buffer we wrote to from the logger, and we write it out to the USB serial port. What's the project about overall? I have a command for that. And I didn't type the right keys. And we're making a keyboard, so it's all about designing, building, and programming my own keyboard. It's going to be a split keyboard like the Corn that I have right here. Only it's going to be of my own design. So we're going to get into the PCB in a little bit, but I'm doing a lot of the firmware stuff up front because I like to do software most of the time. Okay, see you, Gadan. Thanks for stopping by. Okay, so we're never getting into this state, right? I would like to know what state it's in. It's probably crashed or something. I wonder if it's panicking. Or it's looping, maybe? Maybe I should maybe review the differences that I made here. I added that constant of 100,000, and I just used it there, and we're never even really getting there. What did I do here? Added that new state. Nothing of consequence there. We set up a timer there. Okay, so I used to have a hack here. I removed that hack. This is different. The slice used to be a hack. It's not anymore. We should log something here. Well, if I log something here, though, this happens a lot, so we might end up printing too much to be able to send it all back. We actually never saw that, right? It never actually finished sending a sector. Yeah, okay, so it's not getting to this point. Okay, also it's not responding to oh, it is responding to key presses. Oh. Although this bug with the VS Code. Okay, so it's not hosed. It's not stuck. What's it doing then? Maybe I have a math bug in here where it's just not sending anything and it's just stuck in that state. That's probably what it is, right? So I got a math error here somewhere. Oh, this isn't right. That's not right at all. That's not right at all. This math is totally wrong. I don't want to do modulo sector size. I want to do like this minus its, yeah, that minus its modulo, right? And the optimizer will figure it out that I'm going to do an AND with all zeros whatever this is in binary, but you know what I'm trying to say, right? I don't have to explain that. I should, though. The current offset minus where it is in the sector will give us the sector start, right? Plus one more sector, that's the next sector boundary. Yeah, okay, and then I check my math down here. This is also wrong. This should be equals 0. Right? If modulo sector size is 0, we're at a boundary. And this is also wrong. It should be that. No, I don't even need to do a modulo. Yeah. I don't know what I'm thinking here. That should just be that. Okay, let's try this. Reset this guy. Ba-da. Power cycle him. Ba-da, ba-da. I did do a build, right? Yeah. Okay. Alt tab over here, Control C. After I put the cursor in there, Control C, yes, reprogram. Sector 0 sent, waiting for a bit, but it never started programming the next one. So our timer's not correct then. Microcontroller has no internal memory. It does have some internal memory. I'll show you the memory map. So it's got 2 megabytes of flash and 256K of RAM. It's actually got 264, but I didn't bother to adjust this length. I guess I could do that now, but I was going to review the datasheet to make sure I get the number correct. It's got at least 256K RAM. So does it have 16K of internal ROM? We're not even including that. I'm only including the flash and the RAM. I never even bothered to look how much internal ROM we have. It's of no concern of mine because I'm not allowed to write to it. And the only time I read from it is to call the ROM functions. What do keyboards use flash memory for? It has all of the programming in it, so that I can change the program and that I can unplug it, have no power, and it doesn't lose its programming. That's what Sarah Yan said. Why am I answering things that have already been answered in chat? I don't know. I need to figure out why it never got out of that state. Oh, wait a minute, it just did. It just took an incredibly long time. Did you see that? Right as I was looking at it, it moved, and it what is that, 80 seconds? The timer waited 80 seconds? Okay, I'm not willing to wait 80 more seconds. Actually, I guess we'll let that spin for a while, and I'll look and see why is this completely wrong? Oh, I said milliseconds. I mixed up my microseconds and my milliseconds. Microseconds is what we wanted. So it's waiting 1,000 times as long as it needs to. Okay. Control J, please. There we go. Build. So one more time. Ba-da. Flash that guy. We'll power cycle him. Ba-da, ba-da. All right. Controls Alt Tab and then Control C. Terminate. Rerun this again. Here we go. There we go. 6, 7, 8, 9, A, B, C, D, E. Oh, and they're both reprogramming. Ba-da. And they're both resetting? No, the guy on the bottom's still red. Oh, but maybe he's working. Hold on. I never made the secondary controller blink as LED. Well, to test that, all I need to do is swap them. Let's see. If it reprogrammed correctly, then this one will work too. It worked. Cool. I got it working. I think I do want the secondary controller to blink something, just so I know it's alive. So let me make that change. The cool thing is I should be able to reprogram it remotely now. Big's the sector size? 4096. It's actually a typical page size, right? 4096. And I get that from the data sheet. So you should never really guess about these things. I got it from the data sheet. We'll just take a look at it, because I can. It's talked about in the section about memories, which I can never remember where. Oh, there it is. It says here somewhere. Lots of reading, but I think around here. Oh, 16 kilobytes. There's where it we got that number from. The boot ROM. Ah, here we go. For when we erase a flash sector, the address must be aligned to a 4096 byte sector. So that's where I got that number from. And the count also has to be a multiple of 496, because usually when you erase a flash, you do it in units of the whole sector. But program, you can do it in smaller chunks. We do have to be 256 byte aligned, and it has to be multiple 256, but that's the only constraint. Did I obey that constraint in my code? I don't remember if I did. We needed to round up to 256, right? Let me make sure I did that. Program sector, right? Final references. I guess I'm always going up to 4096. Yeah, so well, that's commit. Yeah, we always do whole sectors there. What about down here where I don't do a whole sector? Current sector. Did I not obey that? Did I do partial sector when I reprogrammed before? No, we did a whole sector, so... Min, so it could be less than the sector size, so why does it reprogram the whole sector? Make it blink at a different rate? That's a good idea, actually. Seems that there's one more requirement according to errata, if you didn't misunderstand. When writing flash, an entire 4 kilobyte sector must be erased at a time before any pages in the sector can be rewritten. Yeah, I mean, that I learned years ago, that when you're going to write to flash, you need to erase it first, because you can only write 1 bits. You can't write 0 bits. So if you write and then you write again, you're like ORing the 1 bits in. At best. And maybe it's even stricter here where it just won't let you until you erase it first. Current sector size. Wait, what if we get to the end? And we don't get up to a sector. So wait a minute. Oh, right. Wait a minute. It can't have been exactly that. Yeah, it's less than that. Oh, did it program it too quickly for me to see that? Okay, but what? Okay, here it is, 724. Okay, so we're not obeying that limitation, right? I should probably fix that. It says it has to be a multiple 256 bytes, and it's not right now. I need to make sure, we need to obey the data sheet. even if I'm getting away with not doing that, we should do that, because maybe we're not writing the last sector correctly. Oh, wait. We resized to the sector size. Okay, so then I don't need to do that, but I am. I'm writing the entire sector with zeros at the end. I should probably put that in here. Round up the number of, well, it's not really round up, it's 0 pad. The data to be written. 0 pad to a whole sector. The data to be written. Yeah. That's what this is doing. That's 0 padding it. Then really what I should do is put that comment with that and then move this down to here. And the info kind of goes with the flash, right? Yeah, okay, so then no problem. Then the only thing I wanted to do then to finish this out was to blink. We're thinking blinking it at a different rate if it's a secondary controller. I need to write something coherent there. Okay, here's the NeoPixel thing. We're doing it if it's the primary controller. Okay, then we're gonna move this out to here, right? Else some other number. Let's NeoPixel. How about primary and secondary? Maybe blink it twice as fast? Why not? Let's build. Okay, now where do you program from here? Four, 5, 6, 7, 8, 9, A, B, C, D, E. There they go. Ba-da. Wait, he didn't finish. The secondary board didn't finish reprogramming. Okay, so then we still have a problem then. The secondary board is not reprogramming itself. Ba-da. Yeah, he's dead. Ba-da. Oh, he's not dead. Secondary board is not blinking. Oh, I know why. I'm dumb. I left in that line of code that says only blink if you're a primary controller. I left that line in. Right here, right? I needed to get rid of that line. We always blink. Because we like to blink. Build. And program. There we go. You can see it, right? They both appear to be blinking at the same rate, though, so something's wrong. Okay. Oh, because we don't know if we're the primary board. Okay, yeah, that's another problem. We don't know we're the primary controller until the USB stack gets set up. I need to fix that. So, yeah. There's a complicated reason why this function doesn't work at this point in the code. It's primary controller. If we look at it, it's only if the USB state isn't configured, but we're not going to be configured when we first start. We're going to be in default. We don't get to configure it until later, right? Let's see where all these are called from. Yeah, so I think we're staying in that state. I originally thought that we'd be going to the address state, but I think the progress is default, addressed, configured. And we sit there at that state. So does that mean that I should really just call this when I see the state change? So then what, we would start with that interval, and then we would restart with that interval if we see it configure, I guess? It'd be nice to if we knew when it was configured. Like if we could get a callback when the state changes, but I guess this probably doesn't have that. It's this thing. Self-powered. I wonder if we could call that and figure it out. I'm curious. Let's just log that and see. So if I go back, what if we just print that out? Curious to see this. Are we self-powered? The answer is self dot USB dev dot self-powered. If, then yes. Else, no. Curious to see that. Wonder what that does. So we can force a reset. Poll. We only know if there's something changed. Control in, control out. get descriptor, reset. Okay, so there's not much, there's no way for me to like use the observer pattern or anything like that, if anything fancy like that. So I guess we'll just have our own shadow state. Yeah, so this is just going to, it's going to assume it's a secondary controller until it talks to the host. So that's going to be that to begin with. I guess we'll just have a state here. Let mute USB configured. False to begin with. I guess we'll do it, well... I mean, I guess I can just check it every loop. Yeah, why not? That's just this thing. Oh, there we go. That's the line I wanted. Actually, then... why don't I just do that? And then just change this. Was primary controller. If not was, we're gonna set it to true here. I guess that means it's possible for us to no longer be the secondary controller. And yeah, I guess we'll just be changing our blink rate whenever one of these things happens, right? So we would change the spec to primary. Right? Let's try it out. So I guess if I continue to give power to this and I unplugged it while it was still on, it would say, oh, I guess I'm a secondary controller now. Program, here we go. Reprogramming. Ba-da. I don't think it worked. Ba-da. Ba-da. I'm missing something. Ba-da. Ba-da. Yeah, it's not blinking. Why you no blink? Oh, no? True, set it to true. Else, set to false. Oh, yeah. This should say if it was the primary controller. It's always gonna keep resetting its timer. That's what it is. It's gonna keep resetting its timer and it'll never blink. The same kind of standard available microcontroller? Yeah, let me put that in chat again. It's made by Raspberry Pi. It's the RP2040. There we go. Now it's blinking twice as fast if it's the secondary. Looks like the one issue is that the secondary isn't being reset after being... No, it was being reset. It's just we couldn't tell because it never changed its LED state. And it never changed its LED state because I was foolishly continuing to reset the timer, like every loop, because it wasn't checking that. Yeah. Okay, so I'm going to check it in, and then I'm going to spend some time refactoring, and then I'm going to break out the KiCad and do some PCB design. me check this in. So what changed here? Okay, this is a worthy of its own separate commit, right? This is extract constant for sector program time. All right, and this was basically fixing the whole problem with programming the secondary controller. We introduced a new state called pause between sectors. I guess we could check this in separately. This is just clarifying. Let's just stage this change. Stage selected range. This was just clarifying the comment that why we're zero padding. Yeah, let's put this in. Clarify that we zero pad sectors when programming. Separate commits for separate reasons are always a good idea, right? Okay, so we're back to this should be its own commit too, right? It might be hard to separate that out. Let's try. So stage those that, right? And then we're just care about the blinky parts of the code. Oh, I never did look at that. Are we self-powered? I never printed it. Hold on, let me reset it. It never printed it. Why did it not print it? That's odd. Okay, we'll have to debug that in a second. It never printed the result of that question. Are we self-powered? Yes, no. Okay. This I do want to stage, right? Just this line, though. And then stage this. Right? Yeah. And then always blink. Yeah, so all of this gets staged. Okay. Nothing else is related to... Okay, this is. We need this line. We're just checking in the blinky code. None of that's related. All right. Blink. No. Make secondary controller blink to 2x rate. There we go. All right. Enough separation of concerns. So then this last check-in is purely adding a pause between between forwarding each sector, right? Yeah. And then taking out my hack at the same time. Fix problem. Forwarding program to flash. Between each sector, the secondary controller will need some time to erase the sector and write it and program it before it will be able to service its serial port again. Just have the primary controller wait. Between sending sectors. There we go. Okay, now I want to find out why it did not actually print the answer to this question. Do you have a file system on the flash memory? No, I don't. I just use it as a block device. And I have a very crude usage of it. So back to that memory map for illustration. See how there's two things listed to the linker? These are the only two things the linker cares about. That the first 256 bytes we're using for the second stage bootloader. So that's sort of a convention with this chip. That is the only part of flash that is accessible, and it's actually, I think it's copied to RAM by the first stage bootloader. So our second stage bootloader has to fit into that section. So the second stage bootloader enables reading the rest of flash. And so I, just because it's convenient, I put my program starting at this address, 256 bytes in, right? So our program is going to go from there to however long it is. Now, 1 megabyte into it is where I'm using the staging area for when we do reprogramming. So when I send a new program to the controller, it's going to write it at the flash address that plus 1 megabyte, so halfway in. And when we receive the entire program, then sector by sector, we copy out of the staging area into RAM and then write to the actual location in flash, destroying our old program in the process. So to make sure that that actually works, I do that in a special function that always runs from RAM that I call the commit reprogram. It's always in the data section in RAM, and here's the loop here. We just copy a sector at a time. So it's just a very crude way to organize the flash. So again, the top megabyte is the boot second stage loader and our program, and the second megabyte is I just treat it as a staging area. Your board should have 8 megabytes flash, not 2 megabytes, it says in that map. Really? Well, it was the datasheet that said I only had 2. Right? No, it was the Adafruit, the other one. The KB2040 walkthrough. I thought it said 2. Did it say 8? Do I actually have 8 and I didn't know that? Oh, I do have 8 megabyte. Ooh. So I got confused between the Pico and the Keeb 2040. Nice. So that means I'm totally not using 6 megabytes yet. It's a controller based on the ARM processor. Yes, it's a Cortex M0. I think it says that in this one too. There we go. It is a 32-bit Cortex M0 plus dual core. We're only using the first core right now, but we can take the second core out of sleep and have it do some interesting things later, as long as I'm careful not to do anything that's not thread safe. Yeah, 125 megahertz, around that. It does have 264, and I only have my memory map going to 256. And I think that was because I copied it from someone else who didn't recognize that we actually have an extra 8 kilobytes there. We don't have any EEPROM, so we only have flash. So if I want to have persistent memory, I have to dedicate some part of flash for that. But yeah, I was wrong. We actually have 8 megabytes, not 2. So that means I can change this to 8196. Why don't I just fix this right now? We have 8196. And we actually have 264 there, right? Done. Do you need to cross-compile the Rust to ARM? Yeah, so I take care of that in my .cargo config. So we just set in the build section that our target is thumb v6m non-EABI. That tool chain does not come with Rust when you install it normally, so you have to add it with rust up install, I think it was. And then you just say rust up install this, and you get that tool chain. And then because of how the crates that I'm using provide the second stage bootloader and do the management of the exception vectors and stuff like that, we have to add a linker arg to add the linker script that comes with the crate that I'm building on top of. and then it includes my memory map. So that's kind of weird to have to explain that we have memory.x, but we tell the linker to link with link.x. Link.x includes memory.x. And to find link.x, I have to crawl through the crates that we include. I think it's one of these two. I can't remember. I can never remember which one it is. But yeah, so the we're cross-compiling for Cortex-M. We're using crates from the RPRS group that handle a lot of stuff for us. We just have to provide our memory map for our particular chip, because there are lots of Cortex-Ms out there, and ours is very specific. They differ a lot in the memory map. You know that meme with multicore and road repair? No, I don't know that meme. Let me make sure that this actually builds and I didn't destroy anything. So that means I can move our stage to plus 4 megabytes, right? If I want it. Still works. Let's try moving the staging area to plus 4 megabytes. I put that in flash, right? And this is where the power of constants comes into play. So I should have a constant here somewhere about where my staging area is. Uh-oh, where is it? Is it not here? Maybe it was in keyboard.rs. No, it's got to be in flash.rs because this commit... Oh, no, the commit doesn't know. It's told where it is, so it must be in keyboard.rs down here somewhere. Here it is. 4 megabytes. Let's do it. I was thinking the same thing, Sarian. It's slower because it's a UART only at 115 kilobaud. We could increase that baud rate and see how fast it can go. I thought I remember reading from the RP2040 that it can go much faster than 115 kilobaud. Okay, there we go. We're using a staging area at plus 4 megabytes now. Oh, why did I do that? Just run there. All right. Checking those changes. So this is correcting the memory map. No, we can change these. We can commit these together. Update memory map. Update. Memory map to match KB2040. And the other one was move reprogramming staging area to plus 4 megabytes. Summary for this is corrections for to memory map, I guess. Okay, so why did I pick 115 kilobaud? Why can't we go faster? I want to find out why. It had to do with the one of the constants we use, right? This one, yeah, because it's not a common config, right? I looked at these common configs and I saw that was the highest one, but we could go higher than this, right? What if we tried to just look at the datasheet and see how fast we should be able to go, right? At some point, we might not be able to go as fast as the datasheet says, right? Because I'm going over these flimsy wires, and at some point it's just going to have, it's just not going to have enough, it's not going to switch fast enough because of these long, it's going to provide some resistance, and it's not going to be nice square waves anymore. We can see how fast we can go, though. Where would it say this? Under UART, maybe? Table of contents. Where do we talk about UART? Right here. How fast can they go? Supports the maximum baud rate of UART clock over 16, 7.8 megabaud at 125 megahertz. But we're not running at 120. I don't know what our UART clock is. Do you have any experience with Army Systems development? A little bit. At my last job, not the current one, but my last one, I made a operating system for an embedded device that I just based it off of free RTOS. And there was another thing in there. It was like, I can't remember what it was. There were two devices. One I did free RTOS on one. The other one was like a special FPGA based core, a CPU core, and that it came with its own SDK, and I used that. Like to know, you think it's a nice square wave? Nah, with these wires, it's gonna be kind of sinusoidal and it's gonna be curved at some point. So we just need to use an uncommon UART config, right? Let's try it. Let's try an uncommon UART config. How fast do we want to go? I mean, this can be anything I want, right? It just has to agree on both ends. So if I change this, I got to reprogram both boards separately. Let's try, it says I can go up to 7.8 megabaud. So let's just go to 4 megabaud. Right, why not? Does this not work? Oh, they need to import these things. Okay, what's wrong with this? Cannot create non-exhaustive struct using what? Struct expression? Say what? Cannot create non-exhaustive struct using struct expression. Did I am I not allowed to just... No, it's a public structure. Good night. One kid going to bed. Wait, what? Filter on Rust C to learn about target-specific information? Oh. Release goes in front. So release... I'm confused. Why can't I run Cargo Clippy right now? Going to fourth recently and they say it's used for microcontrollers. That's how you're here today? Fourth. That's a programming language, right? That sounds really familiar. But I don't remember it. Oh, I know what I'm doing wrong. It has to use the nightly. There we go. Cannot create non-exhaustive struct using struct expression. Could you explain Rust C, please? The struct enum or enum variant cannot be instantiated from outside of the defining crate as it has been marked as non-exhaustive, and as such more fields variants may be added in the future. It could cause adverse side effects to this code? I didn't know you could do that. So I can't create my own? Oh, it's this thing. Why did they do that? Did they give me a way to make one myself that's not a standard config? Hold on. Let's save this. Undo that. Paste that and comment it out for a second. How is this made? Okay, it's just manually constructed. So how do I make one then that's not a common config? Will that work, Sarian? I guess I could try it. I'd never heard of this non-exhaustive stuff before. Fault. Nope, that didn't do it. Cannot create non-exhaustive struct using struct expression. Yeah, I've never seen it either. I didn't know there was a such thing as non-exhaustive. Can't actually create, yeah, can't actually create this. How do I make one then? Non-exhaustive is a breaking change most times, so people just update the struct instead. How are you doing, Prof Elements? Shall I go search the web? Okay, specifically, where are we? Like UART config? There's an issue for it. UART config cannot be constructed. Users, this crate cannot actually construct an instance of this type. There are a couple solutions. Remove non-exhaustive. Add an impl default. Expect people to take a common config. Introduce a builder pattern. Wait. Impl default for your is probably the same. Oh, okay. So what? I do default and then I change the baud rate. And then mutable, right? $4 million baud. And then use UART config here. Yep, there we go. See ya, prots. 1311. Let's try 4 million bauds. So this is probably not going to program the slave correctly, but that's okay, right? Actually, no, they're being programmed together, so it should work. That went a little too fast. I guess it can't handle 4 million baud. Should just go in half until it works. Let's go to 2 million baud. This, right, they can't program each other, right? So I gotta reprogram separately. Actually, I can program the primary one just fine. But then I gotta swap it to do this one. I don't think that actually worked because actually the way to tell if it worked is if I hit a key on the secondary. Oh, that's working. Okay, so 2 megabyte works then? I don't think it actually reprogrammed the secondary one at all. It didn't actually work, did it? Yeah, because this one never... Oh no, there it went. So it lost, it had severe data loss. Okay, so we'll try half that. So one megabaud looks like maybe we can do, because we can almost do 2. 1. Build. I gotta do each side separately because they can't communicate the same baud rate yet. Okay. Reset that guy. Oh, it's not working. Well, how come these peer reports are getting through then? Yeah, it still has data loss. I don't know why I keep unplugging it. Like, it doesn't matter. I can just go program this one again. So to 5 kilobaud, 500K. Just keep going down until it works, right? I forgot to hit save. And then that won't work. Yeah, see, it's all garbled. When they don't agree on the baud rate, the communication gets garbled. Okay, now they should agree on the baud rate, right? Now it should work. Yeah, then, okay, so we can definitely do 500K. We can't do a megabaud, but we can do 500K. Right? Verify. I mean, it's a bit faster than it was before. All right, cool. I like it. So we increased the speed a bit. So let's delete this. So I'm gonna do another trick to make sure that we don't need this to be mutable. I don't know if I need to do this. We can make it mutable only inside a block here, right? Is that worth it? Or does that make it ugly? Just to make it only mutable within that block. Is that better like that? I think this is better, even though it doesn't need to be mutable beyond here. Well, it's going to consume it anyway. Okay, it doesn't even matter. All right, let me remove the warnings. Do we need self there? I guess we do. Yeah, we need self there. Okay. Alright, the change was to increase the serial port speed to 500 kilobaud. Increase internal UART rate to 500K. Kilobaud. Git push that. Okay. Clean up code or do PCB work? I really do need to clean up some of this code, right? It just looks ugly. I need to fix that. Okay, first of all, what should I say here? What are we doing at this point of the code? I guess at this point we're polling, right? Poll the... We're going to rename this in a minute. It's not the serial input state anymore. It's like... What does it represent? What does this represent? This really represents the keyboard's overall management state, right? We're either in normal operation mode or we're going through a programming cycle, and perhaps we might be doing other things too, right? Or is this completely programming related? What do I use normal for? Just use normal if we're not programming, but what else might we use the serial port for? If we use the serial port for something else, it would just be in this normal state, wouldn't it? It would just be an else. It would just be an extra else case, and else, you know, check for something else, right? Maybe serial input state is the right term because it's how we interpret, but it's more than how we interpret the serial input. There's also these states that have nothing to do with serial input. I feel like there's two concerns that are overlapping here. There's the concern of how to interpret serial input characters or bytes, and then the other concern is, are we programming, and if so, what state are we in? It's like there should be a programming state as well as a serial input state, right? And the programming state would cover these three here. And we could continue to receive serial input while programming. There's no reason why we can't. This does need to be a specific serial input state, and so does this. These don't. So, yeah, I think I should separate this, right? Here's the clue about why it doesn't belong, right? These three states had nothing to do with the serial input, so that's why they're do nothing match. They're do nothing arms there. Okay, so yeah, let's fix this. So those are the only serial input states. We also have programming states. And I guess we need to introduce a new one, right? That we're not programming at all. Inactive? Yeah, let's do that. Okay, so then I can remove some of these states, right? Oh, but we need to trigger programming. Yeah. So that makes this next function a little bit more complicated. What was that size again that returns the number of bytes consumed? Okay. I think we can just have it like also return an optional programming state. And then we can just say let mute programming state equals none. And then we can say programming state equals programming state commit. And take that and put it there. And then I guess we would go back into normal, right? Oh, this should be some. Right, and then I'm going to get rid of these, and then return this back out. There we go. Yep. Right. I think the way I handle this is I'll say if let some programming state equal programming state. Else do this. And this is going to match on that. And actually the only one I really care about is commit, so it'll be if programming state, or if matches, right? I always forget how matches works. Is it the variable and then the pattern, or is it the pattern and then the variable? Variable and then pattern. And then that's where we do this right here. Then I can delete all this nonsense. Wait, huh? R. So if we have a new programming state and it's commit, then we're changing the state of the color of the LED. Really, this whole thing is LED control, right? So I should just refactor this out anyway. But then we also need to store it. So that's independent of the LED stuff, really. Yeah, let's put it here. Right here. Okay, and then we want one of these up here. Okay, and then initialize it here. Keep forgetting the R in programming. Inactive. Okay, and then... Right, so then this makes more sense here. Update programming state. Or really, it should just be pushing the programmer into the next state, right? Like process the programmer state machine. Yeah, it should be. It should be this. Okay, so then, yeah. Self.programming state equals self.match that. Now it makes more sense that it doesn't have nothing to do with serial input, right? And we'll soon be moving this out to its own function. Cool. No problemo, right? So separating the concerns, I can actually move this into its own function called the programmer if I wanted. And I think actually I might want to do that. Programmer could just be, this should just be called programmer, right? Yeah, why don't I just do that? F2, so rename it programmer. And we'll make a new file called programmer.rs. And in keyboard, no, it has to be in main. In main, declare the mod programmer. Before I extract this out, does this need to have access to anything else in self? It needs is primary controller, it needs the watchdog, it needs the serial port, it needs the NeoPixel. Okay, that does need a bunch of stuff. So maybe it doesn't make sense to move it out to its own module yet. Actually, that's all it needs. It needs the watchdog, the NeoPixel, the serial port. We could let it borrow those things, right? This type is already explicit. Was I gonna make a type for that? Extract it and pass them in? Yeah. Oh, I did make that static. I remember that now. Yeah, it was complicated to have a timer for it, unless it was a static timer. Does that mean that I did a box leak when I actually make it? This guy. Oh yeah. I box leaked a timer. This timer specifically for the NeoPixel, right? Oh no, it's also used by the logger. Why did I do that? Why does he need a countdown again? Oh no, he has a timer. Oh right, right. The timer is leaked. Yeah, okay. I remember this. It's there. It's leaked, it's static. Okay, back, let's go back. Back. I'm thinking that if I make that a type, I'm kind of locking down the resources it's using, but maybe that's okay. Because why would the programmer use any other thing? Why would the whole firmware use any other thing? Well, conceptually, the programmer might use any LED, or might use any smart LED, right? In fact, it might use any LED, and so maybe I would have I would have a trait object, or a generic through that trait, right? Yeah. Don't overgeneralize. I can do the generalization later. So right now for now I could just make a type def for that. Yeah, I'm thinking too far ahead. That's what I'm doing. I should just say self dot, well, it's already here. Just say this dot next, and we'll be putting in here in the parentheses the things that it needs to borrow, right? That's the correct key to type. Okay. Scroll down to where? That's a lot of code, actually. This much of it. All right, and then that moves into programmer. So, impl programmer. Public function next. Self. Self. Paste. All right, and now I need to move the definition of programmer out. This guy. and paste it up here. Okay, yeah, those move too. These move out. I would love to get to where I'm a good enough Rust developer that I could do this in the first pass. I always have to do this in the second pass. So this should just be self. Okay, so then we'll have like is primary controller. And then we'll just remove the self part. Not a function call anymore. Because it doesn't need to be. I'll just call it when we call next. Import create flash, right? Yes. Okay, yeah, the flash staging offset. Where is that used? It's used down... Okay, so it is used in multiple places. Really, I should be searching here so I can see it in both places. So let's declare it. Used it there, but it's used a lot here. So why, how do we get it out of the programmer here? I think it just has to be declared by the programmer as public. That makes sense to me. Either that or we need to tell the programmer the address. I think it's just simpler that it's a global constant, so it'll just be here. Okay, and then here we'll have to make it public. I suppose that means these other ones have to be public, right? Let's see what we can get away with. Import it. Import that. And on here, the self.is primary controller. Okay, and then what is this? Is just what it needs, right? Yeah. So we need watchdog. We need sector size. We need min. We need flash space. We need the serial port. We need the neopixel. Core error once. Smart LEDs. That one. Oh, it needs a timer. Okay, fine. Extensions. Where is it? It is as underscore. I don't like to bring in the name if I don't use it. So watchdog, timer, pair serial, timer. Okay. First things first, it needs a watchdog. Yeah, mutable reference to watchdog. I'm guessing that's the type. Okay, back here, it's mutable reference to the self.watchdog. So far, so good. Next, peer serial. Peer serial. Peer serial port. Wait, what? Type alias exists, but it's inaccessible. Oh, did I type def it here? I did. So I guess they can import from each other, right? Really, it shouldn't, though. I ought to put this in main then. Right? But then I gotta import all these things. That's okay. Look at all these things I'm having to import. Okay. Don't need these anymore. Joys of refactoring, indeed. But the joy is when you finally get it cleaned up and it looks nicer. Import it from the crate. Okay, and I'll need to do the same thing in programmer. Import from the crate. Nice. Okay. Let's use it. So, whoops. There. Oh, we might not need mutable access to it, actually. Dang it, I keep hitting the wrong button. Delete. There we go. Yeah, we don't need mutable access to it. Just be immutable. There. Ah, again, the wrong button. Slow down. Hit the correct button. There we go. So down here, delete that. Okay. Okay, what's wrong? Whoa. Oh, right. It needs mutable access to the watchdog, immutable access to self.peer serial. Okay, good. Moving on. Now it needs the NeoPixel and the timer. Okay, let's do the timer next. I'm kind of starting to think the timer should be... the timer should be, like... No. The timer should be part of the programmer, really. It doesn't really go with... Okay, we'll just keep it here for now. Some timer lifetime. Hey there, A Squared. How are you doing? Just refactoring. I finished the main goal of today's stream, which was to get the boards to program each other. Do some refactoring and then maybe some dive into some PCB design. Does this count down capital D? Yes. Okay, and then I can... Okay, I need to pull in the count preload thing. Okay, fine. So if we pull in that thing, whatever it is, we're pulling it in without its name. Okay, so now we're just down to NeoPixel, and this has to provide access to the serial. No, not serial. What was it? Sector programming timer. I really want that to be a member of this thing, so we'll fix that. Okay, so now it's just NeoPixel, and this is the tough one because it's an exotic type, right? I think we need mutable access to it. Here it is. So we're gonna have to import a bunch of more garbage. Just so that we can get rid of self. And we need smart LEDs right trait. And you can borrow it. Borrow of partially moved value? Oh, we can't do that. Right. I ran into this before, right? Didn't I just fix this by making it an option? Same as with keyboard report, right? No, actually that was different. How did I fix this one last time? Where it pulled it out of itself and then put it back in. That was with the serial. I think the way I did it was I didn't make it part of self at all. It was the serial input state, right? So can I do the same thing with programming state? I think I can. I think this doesn't actually need to be here. Oh, but it... Okay. Right. It has to be returned out of process serial input as well, then. Okay, yeah. So we're going to move that out. We're going to, like, declare it here and run. Actually, could put it right here. Programming. I need to rename that in a second anyway. In a second. More like 60 seconds, but that's okay. We'll fix that in a little bit. Yeah, here's where it's no longer self. We can do that. It's inactive by default. Okay, then the wrinkle is that we might want to return it out of process serial input, so then I'll just put it here. This is a bad name. Actually, it all comes out of this right here, right? Yeah, it's going to be an option. And at first it's going to be none. So So then I don't put that there. And it falls all the way out. Down here. This doesn't feel, the name doesn't feel right. But we'll fix it. Oh, R. Just call the primary function thing first. I want to glob import the prelude. I don't like glob importing because I don't know what it's pulling in. I'd rather be explicit about that stuff. Okay, so it has to propagate out of pull USB 2. I feel like this, instead of being programmer, it should be like programmer command or something. And the command should be to like start programming. Just get it to compile. I'm finding that making that mistake over and over again tonight. Forgetting the R there. That's actually the wrong. Yeah, I think this needs to be another type. Not programmer, but like programmer command. It all originates from here, right? This variable. Yeah, it's like we've received all the program, now program with this size. Yeah. I need another type then. But that can be internal to keyboard.rs. Yeah, so let's make a type for that. Wait a minute. Yeah, okay. So we can put it here. So what will it be? Programmer command? Actually, I don't even need to make a type. It's just an option size is all I need, right? Trace. Where am I going? It's this one, right? This is just U size. Let's just rename this right now to program. Again, I misspell it. Okay, slow down, slow down, slow down. Program. My key combo to type in a function key, I'm not used to doing. Yes, so they don't need this if. Shouldn't this have... Wait a minute. What did I change here? How did it return it out? Shouldn't this just have borrowed it? Okay, it could just be is some. Yeah, okay, and yeah. So then this is next. Yeah, this should be optional use size. Again, rename this. Program equals some receiving size. Okay, better. Where's my error here? Oh, it's U32. Okay, fine. Fix the type. Yeah, which makes this a U32. Maybe I should make a new type for that. I should make a new type for that. So, type program command equals U32. But I should give it a name. So let's make it a struct. Sort of a lame struct. It's only going to have one field in it. Size. U32. There we go. All right. So then it comes from next first, right? Yeah. Option program command. So program equals down here some program command size. I guess that makes it easier to read, really, even though it's sort of a lame structure. Yeah. Okay. So then process serial also returns a program command. And so just pull USB. Okay, it's not programmer anymore. It's program command. Let's get these names straight. Okay, then all the way down here. Right, so this is, here we have a programmer. And it's inactive. And this should be like program command. Right, and it can come from either one, right? Yeah. So let's make this mutable. No, that's not right. If the program command is something, we should advance the programmer, but we can do it from two different spots. That's the problem here, right? No, it's not mutable. It like is given something there. Yeah, and then, yeah. Can't assign it twice, exactly. So what am I trying to do here? What's the warning here? Assignment never used? What? It's returned down here. It's never read. Okay, but that's because of my other errors. I think I'm going to ignore the warnings until I fix the errors. Yeah, okay, that's the crux of it, is that we can get a program command when we pull the USB if we're the primary keyboard controller. We could also get a program command from the primary one if we're the secondary. So I guess I handle it in either place. So let's make a function, a closure, right? Set up handler for programming commands. Let handle program command equal something. And then this should say something like if let some program command equal program command. If it is something, actually I could just pass it in here, right? I'm can just do that here. And then just always call the closure, which means it has to be callable more than once. We'll make sure it does. All right, and then we'll just call it again down here. Copy that down to here. Okay then, and then the way we would handle it, there's another warning here. It says it's never read. I don't see why. It's assigned here, and then if it is some... Is it because it's mutable? It doesn't need to be mutable. No, it does. Oh, because it's... No, we return it back out. Never read the initial value? Oh, it knows that because we always go through the loop at least once? I see that. Okay. That's weird. I've never made a mutable variable and didn't initialize it, but I guess that does make sense. Okay, so here's where we turn the command into a change to the programmer. It would be self.programmer. And it's not even in self, right? Programmer equals programmer commit program command size, right? And the problem with this is it needs to be annotated, okay? I would think that would be obvious, but maybe it's because there's going to be another error. Yep, there's going to be an error. Cannot borrow handle program as mutable is not declared. Well, yeah. Okay, so can I get rid of the annotation? No. Fine. Wonder why it needs to be annotated like that. Let me make sure I didn't break anything, so build that. I got a program twice, right? Okay, we do have warnings. Private type in public interface. Okay, so need to make those public? Because it's in a public interface. Zoop. Ba-da. Oh. Serial port too fast still? Ba-da. Ba-da. Maybe it's just lucky that 500K worked the other time. Ba-da. I guess I was just lucky before. Oh, now we're getting the are we self-powered? The answer is no. But how come I'm not getting it on this? I reset this guy. Ba-da. The peer tells us it is. Oh, because the peer is writing to a UART. Okay, that's right. No, it should be held in the ring buffer until we can write it out. Okay, that's odd. Why did it not work? Did I break it? I guess I broke it. I broke it. No. All that refactoring and I broke it. It does change color though. Yeah, I broke it. How did I break it? It does say now program size is, it never forwards the program. That's the problem, I think. It never actually got to commit. Well, wait a minute, it should have. Oh. Well, no, it should have done this, right? Should do an info here. Got programmer command. Got command to program. Programmer's not working, so I'll have to do it the old-fashioned way here. Oh, wrong one. Ba-da. 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 And do this one too. Ba-da. 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 You can't tell the inner type of the option, okay? Oh, is this delay again? I haven't seen this in a while where it takes a while to open the COM port. While I'm waiting for that, let's see what where it could have gone wrong. I don't think it actually made it into here. Because it would have done one of these things and it did neither. The serial input. So it would have gone into next. So right into the staging area, right? So I think it writes it into the staging area, it just doesn't get back out again. This isn't working. It should return it though. If it's some... Oh, I see what's going on. It loops back and it's it resets it again. I see the problem. The problem is here. It'll get set to something, it'll change the LED, and then it'll loop. And then it'll be none again. It'll get destroyed, basically. Okay, so we can only accept one program command? How am I going to do this? I mean, it makes sense that it should stay at... It should not go back to none. So if there is more input... Actually, would it make sense if there's more input? Maybe we exit back out. Well, we could receive more input, theoretically, and we can get another program command. So then, I guess... it's possible for this to need to be a vector? Okay. Sure. So then this is vec new. So then this is like program commands. And then if we get down to where we have one, am I doing this in the right place? No, I'm not. It's in process serial input. Yeah, this should be vector of program commands. Because we might get multiples. It's possible the way I've declared this. Okay, so but then this needs to be let program command. Singular. If it is some, well, this should then be if let some program command equal. Then we want to append it. So program commands dot append, no, not append, push, I think it's called. There we go. And then, what's wrong with this? Expected, oh, if let, so get rid of the is some. And then we return the, right, okay, good. Then this needs to be initialized to be vec new. All right, and then, right, so this also could be a vector. Ooh. This has to be a vec new, and then we reassign it. Yes, okay. Then this is that program commands. And then we have to do for each. Handle program command. Does that mean that process serial? No, it's also a vector. Okay, yeah, so this is handle program commands. So this should be for program command and program commands. I don't think I need that anymore. I think I know why it was wrong. Okay. Let's try this. Whoa. Build that. Duh. Tiny buttons. Same guy over here. Try that again. Oh, USB bus got confused. Gotta unplug it. This happens once a stream or so. Plug it back in. And we're back. But I need to reset the camera. That's right. Every time that happens, I gotta reset the camera. Hello. Okay. See if it works this time. There it goes. I fixed it. Cool. Uh-oh. Oh. It broke. My solder joint on that button, on that key broke. Okay, I'll have to resolder that. I'll just pull it out. The solder joint on this broke. Okay, see that? Right there. That's supposed to be glued onto there and it's not anymore. It was kind of flimsy to begin with. Now I'm down to a 1-key keyboard. Did you try JetBrains IntelliJ IDE with Rust plugin? Nope. Why would I want to try? Give me a reason to try JetBrains IntelliJ IDE with Rust plugin. I'm kind of happy with my VS Code, but if there's something about JetBrains IntelliJ IDE that's better than VS Code that I'd like better, I'd love to know. Whole new programming embedded. Well, the what is that button not working now? Oh, it's on the pier, right? It won't work unless it's plugged into here. Now I only have Q, I don't have W. Rust plugin there isn't as well supported. Well, it's going to be a challenge to convince me, Sharpforms, if A Squared, who's knows quite a bit about Rust, and if he has that to say about it, then that's sort of an uphill battle, I think. Yeah, I generally don't try things unless there's a reason to, because there's just too many things to try. A reason might be that I find it fun, but I don't generally like I don't like trying out new IDEs. That doesn't sound fun to me. Okay, that's one refactoring step. So I separated the programmer out of the main keyboard class, and so I could refactor this next into pieces now, right? If I wanted to. I kind of want to turn this, some of these, like the timer should just be part of the programmer, I think. I'll make that something I handle at some later date. So let's just check this in. Okay. I'm wondering if I should just move that back into keyboard, because it's sort of ugly to be there. Let me do that. I don't want it to be in main. Main should sort of be like not concerned about details like that. That should really be in keyboard. I think modules can import from each other. Let's make sure that that is true. So this has to not import peer serial port. I do need to import these other things though. I think I was importing the stuff before now, and then I removed it. Okay. Just need to fix this import. We're all good now, right? And then, yeah, then I can delete all this stuff. Clean this up again. All right. So yeah, we're introducing the programmer module, which knows about the programmer state, which now keyboard doesn't need to be concerned with. So we removed some imports there. We brought in the programmer. We removed flash staging offset. All that's so now we had to define a type for peer serial port to share with. Actually, I think I ended up moving that by accident. Was that somewhere else here? Where's peer serial port? On the left. Okay, I did move it by accident. So let me move it back. So before I had it before keyboard, let me put it there again. Yeah, let's... Whoops. Right before keyboard is where it should have gone. Right here. So then there's net zero change. Okay. It's free like VS Code. Okay. I don't try things just because they're free. I'm sorry, Sharp Forms. I didn't try it, and I'm probably not going to try it because it's free. I don't try things just because they're free. If you said something like, if you try it, you'll win $100, then I'm like, okay, maybe I'll look into that. But yeah, or if you said something like JetBrains ID, IntelliJ ID does such and such a thing better and you'll like it, then I might look into it. But other than that, it's going to be, nope, haven't tried it, no reason to, sorry. Receiving programs there, so we don't need the flash staging offset. It got moved to the programmer, which makes sense. Hey, Owen Codes, how are you? I'm doing a bit of refactoring, and I just got these two different controllers programming each other, which is the main goal today. And I want to do a little bit of PCB work before I go to bed. So I think I'm gonna check this in, and then there's more refactoring I need to do. But I don't need to do it tonight. I should just do it. I should do it when my brain is rested, right? Doesn't that make sense? So I removed some of this stuff, which was a code smell. It was state transitions that did nothing because they didn't really have anything to do with the serial input. So now instead we explicitly give the programmer a command to program if we get into this situation here, which makes sense. So the difference here is that it's public, right? Yeah, that makes sense. And then, so this is now explicitly saying polling the USB could result in program commands, which makes sense. That all makes sense to me. Same thing, processing serial input could yield program commands. And if we get a program command, we want to change the LEDs. Actually, this is going to be refactored to be like update LED state or something like that, I think. Yeah, that got moved around. Now we have a programmer, and we handle programming commands by moving the programmer into the commit state. And then we handle it in two different places explicitly now. And here's where I actually refactored it out, and I actually know what to say. Process the programmer state machine, which turned all that code into just borrowing the things we need. Okay, so I know what to say then. We're going to say commit that guy, extract out programmer from keyboard. Programmer should be capitalized. And we're going to say that a programmer takes over some of the states previously managed by the serial input state machine. Okay. I think I'm done coding for the day. I'm going to move on to something a little bit different. Just waking up, it's 8 a.m. here. Good morning. So let's run this one more time. Just demonstrate what it does. What I'm doing when I say program here is I'm sending through this USB cable a new program to this controller. It programs it, it saves the program itself, then forwards it over this wire to this other controller, and when it's done sending it, both of them simultaneously overwrite their program with the new version. So you see, it sends it very fast, and now it's sending from one to the other, and now it's programming both. Only, okay, I've run into this problem before where I think the serial port is running too fast because we're losing data. So I think I'm going to lower the serial port speed. Yeah, okay. Let's lower the serial port speed. Where did I put that? Close everything. Keyboard, right? And it's one of my constants. No? I thought I made it a constant. I didn't. Okay, we need to make it a constant. Yeah, let's fix this. UART baud rate. Okay, what type is that? I don't know, but I think it's U32. Const paste U32 equals, now let's go down to 400 kilobaud. So I'll have to program these the old-fashioned way with the built-in programmer. And this one. Hold down that button while I plug it in. I didn't quite get it. I'll do it with the reset button here. Those buttons are just so tiny. Okay. Now it's got 400K. Let's make sure it works. So it's a little bit slower, but it should get through all of the program. I think it did it. No. It might have. Look at those. I think it's doing it, but the colors aren't staying the correct color. Oh, I know why. I messed up something. Well, at least it's they're both reprogramming now. So 400K is a better rate then. Let's check that in. Git commit reduce uart baud 8 to 400K. But I was seeing some data loss at times. Actually, what's it doing? I don't understand what is it doing? Okay, I think it's just sometimes not working. I feel like maybe I should reduce it more. Seeing some data loss at times with 500K baud. I have a feeling I'm gonna be reducing it again. Okay, fixing LED state, that it bothers me that I've messed that up. That would, yeah. I think it's here in program process serial input. I think it's getting to, because I'm sending it back to normal and it's doing this again. It's setting it back to green when it shouldn't. I think the problem is that it doesn't really belong in process serial input at all. It belongs outside of this. Yeah, well, I'm gonna fix that another day. I'm done doing this. I'm gonna move on to something else. What I wanted to do was play around a little bit with KiCad. Where did I put that? Here it is, KiCad 6. I guess it has the last project I have open. Let me close that. Let's make a new project. So I need to start thinking about the PCB, the printed circuit board. So to move to the next step past these breadboards, right? So what I'm thinking about doing is upgrading from these breadboards to actual PCB, but not the full keyboard, but maybe a small subset just to prove some things out. And I was thinking of making a PCB board that's actually several different boards with cutouts between them, so I can play around with different kinds of switches and maybe some other things. So I want to make the controllers socketable so I can move them between prototypes, and I want to have play around with these Cherry MX switches, but also some low profile ones which have different sockets. So let's just make a new why is it defaulting to... Oh. I guess I could put it under the rusty keyboard. So call this the PCB. Does it make sense to check it into the same folder? I mean, I guess so. Sure. Okay, so I need to define the schematic first, right? And I need... Let's see if this works right. This didn't work a minute ago. Oh, now it's working again. My auto hotkey is working. Oh, I'm all white. Is that because this is bright? Yeah. Messing up my camera. I don't suppose there's the dark mode for this, is there? Is there a dark mode? It's too bright. Well, I guess we're gonna be blinded. And I'll have to reduce my cameras. Filter. Chroma key. Reduce that. Okay. So what does that do if I take the window away? Ah, I'm still there. Okay. All right. So I read about that there was a library that I could be pulling in. There's a key switch KiCad library that we may be able to borrow from. Footprint library. Yeah, I think I want to pull this in. 3D model for them. That's nice. Okay, using the library. It's meant to be installed via KiCad's plugin and content manager. It's only available nightly builds. Okay, we're using 6. If you want to use Git, simply clone this repo to the directory where you want your library stored and include them manually on your footprints table. If you want to use the recommended method, open the content manager where you find this library in the libraries tab. Note that you'll need to add the libraries to the library table manually. Okay. Why would I need to add the libraries to the library table manually? Alright, anyway. That's what I want to get for footprints, right? Because those look correct to me. Alright, so let me... I mean, I guess I can pull it in with HTTPS. I'd rather pull it in the other way. It's a big... Oh, because I'm not logged in there. Okay, but I am logged in my other window, so I'm going to grab that. Alright, so... I guess I'll pull it in here as a submodule, right? Submodule add how does that work? Again, I forget this. It's repository and then path. And path is optional. Okay. There's a repository. I guess what the default would be just... Yeah. Default's just the name of the repo. Okay, cool. So we're not on the schematic yet. I need to go to the library stuff, right? Manage footprint libraries. Project-specific libraries. Add a row. Okay, this is where they told me to type in certain things, right? Names and locations. I guess that's what they want me to put in for nickname? I guess. What baby magpie? Is this over where you are, Syrian? Or should I be worried that it has something to do with me? Oh, I'm sorry, you have loud magpies. Okay, so why can't I do a local path? Can I just type in key switch KiCad library and then paste that? Such a little entry box. There we go, I fixed it. Okay, let me copy this much of it. Let me just get, whoa, let me just get one of them in there. I'm not going to use stabilizers, but let's see if it worked. Delete. How do I know if it worked? I guess I would go to the footprint editor and see if it's there. Loading footprints. See if that's in there now. Stabilizers. Nope. It didn't work. Okay, I obviously don't know what I'm doing then with the footprint. Oh, that's a footprint library. No, it's not. Okay, whatever I did, it didn't work. Open the Content Manager, where you'll find this library in the Libraries tab. Content Manager. Preferences, Manage Footprint Libraries. Oh, I see. This is different. This is all I need to do, right? So I think I messed this up. Let me add it again. Let's call it, what am I calling it? Key switches? I'll name it. Why am I typing it when I can copy paste? I thought I could do relative path names, but I don't think that's actually working. Wouldn't it open up, wouldn't it show something there if it was? I'm lost. I don't know how to do this. Oh, wait. Hold on. It might... Okay, I think that just their instructions are not very good. I think the footprint library is in there somewhere, but I have to delve down and find it. Oh, and it has its own submodules? Okay. Git submodule. Update init recursive. We're cloning other repos. Okay. I think I need to delve down into this level, right? Is that what their instructions actually said? Oh, okay. It's a couple levels, right? It's key switch KiCad library, then footprints, and then this. Okay. Then library, and then that. Make this wider so I can see it. Is that the right path? Key switch KiCad library, footprints. I don't know if that's working. If I hit OK. Oh, I could use that. Okay, that's I think what I need to put in front, right? Ah. $, bracket, KIPRJMOD, and bracket, slash. Hold on, I gotta take a break for a second. And I'm back. Hopefully I only have to set this up once. Now, did that take? I don't know. But the nickname's wrong. How about put stabilizers? Okay. It didn't find that. Do I need to do backslashes? Gosh, I hope not. I thought that was the path that I had. So it's projects, trusty keyboard, PCB, key switch KiCad library, library footprints. Oh, there's no com blah whatever in there. That's the problem. Yeah, that's close that guy. This one's not there. Hit OK. Footprint editor. Oh, yay, look, there it's there. Here's the Cherry MX 2U. This would be like a shift key thing. Okay, cool, it's working. So let me grab the rest of them. I wonder if I should put something in front of this, like keyboard stabilizers. And then what's the next one going to be? Let's just pull it. Actually, I'm just going to change it to, I only really care about the Cherry MX and Hot Swap Kyle, right? Keyboard Cherry. So let's just change this. I'm not going to have any stabilizers on my keyboard anyway. So the path there is just switch keyboard. Okay. Let's call this keyboard or Cherry MX. I kind of want them all grouped together. So let's do keyboard dash Cherry MX switches. And this is switches. Switch. Keyboard Cherry MX. Switch Keyboard Cherry MX. Okay. There it is. Okay. There's one. What's the difference between these two? I don't know. These look the same to me, only this one's got, what is it? It's not a courtyard. What is that line again? User drawing? It's got a user drawing square around the whole thing, whereas this one does not. I think it's the same, right? And then this is the slightly larger key. I wonder if this is the base and then this is drawn around it. What's plate? Oh, that must be what you... I have no idea what that is. I think this is what I have right now, right? If I wanted to draw where to put the holes on the PCB and stuff like that. Okay, so then... and this one doesn't have a 3D model probably, right? What's the button for that again? Was it just right click? No. Thought there was a button to view the 3D model for it. Maybe if it's... no, that's not it. Is it not in the footprint editor? I can't remember now. Okay, anyway, I wanted to pull in that other library too. Okay. New. I want to do the hot swap Kyle. Switch keyboard hot swap Kyle. Okay, footprint editor. Let's look at these guys. Keyboard hot swap Kyle. Right, the switches, right? So like this should match what I have. Yeah, exactly. This shape where you put the on the back, right? Where you put the actual switch socket, this thing. So that should match that. Right? Whereas this kind of matches what this plugs into. Right? Like hold that where everybody can see it like that with the bump and the two posts on it. Okay. So then oh, it just shows up there because it's in my folder. Okay. If I were to lay out one of these footprints, oh, where do I get the symbol from? Hold on, does this handle symbols too? Wrong thing. This is just a footprint library. Okay, where do I get the 3D models from? The library includes the following 3D models. Okay, does it not have symbols? I guess I just use a generic symbol, right? So I would just do like switch. Or a key switch. I guess there are a lot of things called switch. Analog, can I just close these guys? Switch. It's not what I want. Push button? Yeah, like this. Yeah. Okay. How do I... Did I hit the wrong button and go to the symbol editor when I wanted to do just put down a symbol? Yeah, okay. I just want a new symbol. This one, right? There we go. So I'm going to put a switch here. Cool, got a switch. Now I'm going to edit it. Beep, beep. Beep, beep. Edit is this button. All right, and then the footprint, I'm going to pick Cherry MX switches, this one. And show the footprint. How did you choose to not use the official RP2040? Did you hear about the new Pico W? I am using the official RP2040. That's what these are. These are both RP2040s. Do you mean the Pi Pico? I used these because when I was searching for things, I saw that Adafruit had them. Oh, right, the Pico board. I think it's because I picked it because I'm familiar with the footprint of this Elite C, on Pro Micro. The KB2040 has the same footprint, so I thought it would be nicer because it's something I'm familiar with. If anything, like the form factor of this board, I know my controller would fit into it, but I'm not like completely locked into this board. I could switch to the Pico. I could also just take a raw RP2040 and surface mount it on my PCB if I wanted, right? So I haven't really committed to anything in particular other than I'm probably going to go with this microcontroller. It's convenient to have them on this KB2040, but I could pick up the Pico, or I could surface mount it on my PCB. How did the hot deploy go? It's working now. Should I show you that? So I can just tell this one, hey, go program, and it will program itself and then load onto the secondary one, and then both of them reset together. It's working. The LED states aren't completely cleaned up because I broke that, but that's okay. I'll fix it later. Oh, I didn't want to show it in the schematic. Right. What I want to do is update the PCB. And what's the way to do that? Update PCB with it? Oh, I need to annotate it. Switch 1. Update PCB. Hey, there's my switch. Yay! And I can look at the 3D model for it, right? Where's that button? It's like option 3 or something. View 3D viewer. Hey, look at that. I got the holes for my switch. Now I just got to mount the, flip back to the other. I need to mount the socket on the reverse side, right? So that means I need a socket. Add a socket. Well, it's Kyle, right? Is there no symbol for that? Actually, I don't know what symbol to use for the socket. I don't know what to put for socket on the schematic, at least. I guess I can just mount it on the flip side of here, right? View, flip board view. And I can just place it. Add a footprint. Not a chalk one, but an MX one. And put it right on top, like that. And then let's view it. Hey, look at that. That's where I'm going to mount the... Okay, there's something weird going on. See the cylinders? That's not what I want. And it didn't put the 3D model for the actual socket. Board outline is missing or malformed. I would agree with that. Let's put that here and side by side with it. Yeah, it's not actually, it doesn't include the 3D model for the actual socket. Does it use anything fancy from the Rust ecosystem, or could you easily port the solution to C? I don't think I'm using anything fancy from Rust, other than the crates that I'm using. You should just use the Kyle footprint for the switch, and not this. Well, I think I need at least a silk screen and the pads from the socket, right? But I do need these holes for, actually, no, I don't. You're right. I should just use this one. Yeah, I think you're right. So then delete this guy. How do I delete? I forget how to just undo. And okay, and then switch to the schematic. Edit the schematic. See, I'm totally new to this stuff. So yeah, so instead of using the switch, use the socket. But then it needs to go on the reverse side, right? We need to take this and flip it. Move to back. Where is that? Change flip side. There we go. So view 3D viewer. So there's the front side. And actually, it's using the wrong one. How did I screw that up? I messed it up. Oh, did I not copy from PCB? That's what I didn't do. I forgot to hit this button. There we go. Looks better now. So I just need to flip it to the other side. No, it's already correct. Okay, I don't need to flip it. It's putting the pads on the reverse side. So there's the front, and there's the back. There's a silk screen for where I mount the switch. There's the two pads. Cool. I actually don't think I need these holes, because the switches I have don't have those on them. I guess there's no harm in keeping them, though. What rule am I breaking? I don't have any edge cut, correct. So if I wanted to add that, I would click on edge cut and draw one, right? There. Click once, click second time. There we go. Now I have an edge cut. And DRC. Hey, look, the board's good. Ship it. Just a switch. I'd like to get the 3D model for the switch, for the socket though. I don't know why it's not there. It should show it, right? Unless something wrong with the footprint. Save. Save that. That's the symbol editor. I wonder if I need to pick one of these other guys. I thought that there was a button to see 3D view, 3D model. Oh, it's still there. Yeah, see, it doesn't have it on there. Includes the following 3D models. Hot Swap Kyle. Is that in a different directory, maybe? Oh, 3D models. Okay. All right. All right. So how do I get that attached? Maybe would it be the properties of the overall thing? I don't know. Stabilizer. No, I'm not need stabilizers. Stabilizers are for like if you have a really long key like the space bar or something. Oh, here we go. I need to add a 3D search path, right? Do I need an alias? I need a path here though. Beep, beep. Can I do a relative path? I don't know. Well, I guess I can at least try a... Yeah, let's just try a hard-coded absolute path. No, that's the wrong one. Library, 3D models, 3D shapes. This is probably it, right? 3D search. Okay, how about key switch, KiCad, library. Did that work? Nope. I think this is the socket. It's just, I don't have the path set up right for the 3D model. Course was created to provide high performance comparable to CNC++ with a strong emphasis in the code safety. C compilers don't really care about safety. This means programmers need to take care not to write a program that causes memory validation or data erases. Thoughts? Why are you asking? Any involvement in safety critical systems or life systems? No. Are you trying to open up a new conversation? I'm working on PCBs right now. Is Rust safer than C? Yes. but I guess it depends on your definition of safer. Safer in what respect? Rust is safer than C if by safer you mean memory safety. You're a digital designer. Oh, that seems very vague to me. Digital what? You transfer to PCBs, let's go. Yeah, I'm trying to learn KiCad and importing. I don't want to draw these from scratch. So I'm just trying to draw this in, and I'm trying to get the 3D model to import. It would have been nicer if the instructions here were a little bit better. It just says it includes them, but I don't know how to use it. I got past this. This was sort of wrong. This was very vague. Okay, with this method, the 3D models will not be linked in automatically correctly. So they don't want me to get it from Git. They want me to use the content manager. I'm a little bit hesitant to use the content manager because it depends on, I guess, this namespace always working, and I'd rather, well, I'm already doing that with GitHub with a Git submodule. Maybe I should switch to this way then. Well, this would require anyone who opens my project to do this, right? Whereas if I do it this way, actually, I still would have to, I don't know. I'd have to try, you know what I'll do is I'll set it up, check it in, and see if on my other computer I need to do anything in KiCad or if it just works. Okay, so it's gonna, okay, the way I'm doing it, 3D models are not linked automatically or correctly, but maybe I can figure it out anyway. You have schematic? Yeah, you want to see my schematic? I do have a schematic. Check out my schematic. It is one switch. That's as far as I've gotten so far. So I'm trying to do the fundamentals, like can I place a switch on the schematic and can I associate it with the PCB, which will take a while to load, I guess. And it does. So, except for I'm not getting the socket on the back like I expected. I should be able to get it. This should populate this. It should show the 3D model for the socket, but it's not doing that. But at least it has the pads in the right place. And the silk screens are correct, right? That's where we're going to place the socket, and there's where the switch is going to go through. I just wish I had the 3D model working. What's my goal? Well, my goal is to make a keyboard. My project overview here, if you want to see my notes. It's about designing, building, and programming my own keyboard. So this is a stream 8. See the last 7 streams. I mostly focused on the firmware. I prototyped out a lot of the firmware here. I got all the flash programming working. I have key presses working. I have done most of the things that I need to do in the prototyping stage. So the next stage is to move on to actually making some actual printed circuit boards. So I'm making that next step now. So yeah, I don't have much of a schematic yet because I just started literally half an hour ago. Did I already close the window where I had? I did close it. Shoot. It would be in preferences, right? Not this level of preferences. Footprint libraries. I mean, that's where my 3D models are located. Where was I? Where I was it in Footprint Editor? I think I was in this window, right? And then I had preferences here. Nope, that's not it. I forget where I was. I'm terrible at these things. Was it that I was looking at that this guy? And then he had a So footprint properties. I mean, can I just add a model here? Oh, here we go. 3. That's where it was. Okay, and this is broken. Okay, so I guess it's not working because I see. But I could fix it, but I'd be fixing my own fork of it. I mean, that's not too bad. For a quick, cheap proto JLC PCB, yeah, that's what I was planning to look at. Actually, Adam told me that there's an even cheaper and faster way to do like smaller ones. And you could even get it for free. Or for $10 or something like that. I don't know what Eagle is, or a KiCad is what I'm using right now. Or you mean by Easy EDA? That's the online program that JLC PCB is using. I forget what he said. Where did I write that down? Write that down in my notebook. Links, maybe. I think it was this one. All PCB. Yeah, this is what Adam was pointing me to. Adam's another streamer that has done some of this before. As low as $0. So he was saying that I could claim a coupon, a prototype coupon, and for like, yeah, like for $5 or $10, I can maybe get a small prototype just to test some things out. Beep beep. How come I'm getting a beep beep switching back? Because of this? Alright, let me try to fix this. Configure paths? Ah. Aha. I think I don't want this one, this alias. The problem is in this path here. Okay, so there was a trick here, right, where there's this KIPR. Let me use this. Can I just grab that? It's not going to let me grab that. Dang it. How about if I grab it from... Oh, where is it? Like it's not on my list now. Oh, because it's on project specific. Yeah, grab it from here, right? This part of the path is the same. Okay, can I... Footprint properties, 3D models. Can I just paste to there? Is that the path? Let's see. Library. No, I need to go library and then 3D models. Okay. .3D models. And then 3D. Okay, the rest of the path is correct. Hey, look at that. I fixed it. Look at that. We got ourselves a socket. So, does that mean every single one of these symbols has the wrong save? Every single one of these symbols has the wrong path in it? Yep. Okay, I see the problem. Well, I mean, I guess I could just... This is the only one I'm going to need anyway, right? So I could just fix it for myself and check it in as a fork. See if this actually worked. Update PCB. View 3D viewer. Nope, didn't work. Do I need to... I think I need to go into the footprint and say, like... Actually pick that again, right? Update symbol from library, that was it. Footprint data sheet, sure, update. And then go to the PCB, update from schematic, then view in the 3D viewer. Nope, still wrong. I'll get it right one of these days. I should just slow down here. Update all symbols. Footprint. Let's just do all symbols. Should you just place it again, I guess? Change? What does change symbol do? Weird. So, hold on. If I go here and I say, I don't want to do show here, right? Thought I got it updated. Maybe I didn't hit save somewhere. It's back to being broken. Okay, what did I do? What? Did I do the wrong one? Huh. I mean, you guys saw it. I had it fixed. I guess I gotta do it again. Hold on. Footprint properties. Gotta fix this again. This time I'm gonna copy to the clipboard, knowing that it'll probably delete it. The models. So copy that to the clipboard. Okay. Save. Right? When I view 3D viewer, it's still there. Yep. Close that. Go here. Update symbol from library. Update. Okay. Save. Maybe I have to save every time. Save. View 3D viewer. It's not there. What the heck? Did you know Eagle already, or is this from scratch? I don't know Eagle. I had edited a different object? Really? I have to push from schematic. I thought I hit that. Update PCB with schematic changes. Update symbol from library. Update. What happens if I hit edit library symbol? Oh, that's the symbol in there. Okay. Save. I'll get used to this eventually. Figure out what I'm doing wrong. It's not there, so back to the footprint editor we go. You think I should delete the PCB and create it from the schematic again? I thought I could just update from it. View 3D, and yeah, so it's still there. So you guys are saying that there's another one that I put the 3D model on. I don't know which one it was. Maybe this one? No, it wasn't that one. I think this was the one I have the 3D model attached to now. That's the one I want. Yeah. Yeah, I've never used this before either. So make sure I'm using the right, so I'll keep this one up. Pretty sure it's the same one, right? Yep, you can see the socket on the back. I don't think I need to hit show, but I'll hit that anyway. It just adds some extra layers in the schematic. Update PCB with changes made to schematic. There's relink footprints to schematic symbols based on the reference designators. I mean, I guess I'll click that too. And then view 3D viewer. It's still not there. Well, let's delete it. Delete. Beep. I can't delete it. Cut. Okay. All right, here's my switch again. Okay. That brought it back. Why is it green? I made it green somehow. Is it because it's selected, maybe? Yeah, it was good. Okay, that was weird. I had to delete the footprint and then bring it back for some reason. So if you're a hot deploy code, did you need 2 of the chips? I have 2. I'm gonna have 2 of the chips because I have a split keyboard. So it's simulating the same thing you'd have on this Corn keyboard, right? So there are 2 controllers there. They're connected with a TRRS cable. So I'm going to have the same thing. Haven't decided yet if I'm going to use a TRRS cable or maybe just use a USB-C. But in one way or another, I'm going to have 2 wires plus power and ground, so that the side that's connected to the host, my computer, will provide power and ground from the host over to the other side, along with data in and out, and the having one controller program the other is just a convenience. Like with my Corn keyboard, to program both sides of this, I got to program the left side and then unplug it and plug in the right side and program that, and it's just a hassle. So that's one feature I wanted, was when I program one side, it automatically reprograms the other side too. Probably green because it's not routed open yet. I don't know. I think it's just because it was selected. So if I do view, or was it select all? I still need to get used. I really need to get used to this. So if I do select all view 3D viewer, I think it shows it in green because it's selected, right? If I click elsewhere and 3D viewer, it's back to black again. All right. As you could tell, this part of the stream is just me getting familiar with the tools and setting them up right. So what I did should have showed up as a diff, right? Oh yeah. Well, that's interesting. What kind of diff is that? it modified the footprint with a bunch of changes. Did it just rewrite it? Oh, the model is different. Yeah, okay, the model is now based off of where my project is. Okay, I see that. Yeah, and there's there's other inconsequential changes in here. Like there's a version number in there. There are quote, double quote characters there that weren't there before. Okay. This must be the one that I changed by accident. I changed the chalk switch, the chalk socket by mistake. Yeah, there. Yeah, okay. You guys are right. I changed the chalk socket by mistake. Back to the footprint library. Footprint editor. I must have gotten and clicked on one of these, like this one. Right? Let's see. It doesn't look right though. I must have, right? Because there it is. This is a low profile switch. I mean, I was eventually thinking about trying this out anyway, so I guess it's okay. All right. Okay, there's our tiny board. Okay, I figured out I don't need to show there. Okay. So we have one switch down. Let me add a socket for the microcontroller. So hopefully we have that IC socket. Do we have a dip switch? Not a dip switch, but dip socket. I'm gonna have to pull in like I might have to pull in another library, right? There was another one I was reading about that DigiKey hands out. Did I have that in my links? I don't think I do. Let's look for it. DigiKey KiCad library. Here we go. Yeah, here it is. So actually, I'm getting my footprints and my symbols confused. Really, I don't want to put a socket down. I want to put a custom symbol down here and make the footprint of that symbol be that socket outline, right? So don't I want to just make a new symbol? Actually, and I want to make a new library, right? Project local library. Don't know why it's going there. PCB. Let's call it project. Okay, and then under project, new symbol, symbol name. KB 2040. I guess this is all fine. Okay. All right, now I gotta get the physical dimensions of this thing correct. Really, I want, actually, I just want the pins. So I don't really care for now. So why don't I just add a rectangle and edit that. Fill with background color and just leave it without pins for now. Because I don't want to fill in the pins yet. I'm too lazy. I just want to have a symbol and then symbol properties, footprint. Here's where I want to grab a socket. Yeah, I want to dip, what is it? 28. What's that? Okay, this isn't right. I guess I need to get it. I need to get that digital key thing anyway, right? Because I want a socket similar to like what you'd plug these into. Because I want to be able to hot swap the controllers. No, not hot swap. I want to be able to swap the controllers out. Unplugged first, but maybe one of these, maybe? Oh, here we go. Pin socket. I don't know what this measurement is here, but let's guess 2 millimeter. I want a 2 by 28 at least, right? Oh, that's not exactly right. I don't know what I'm looking for. It's not that, though. That's not what I'm looking for. 2.54. Nope, not what I want. Back to the web I go. So KiCad, footprint, IC socket. Yeah, dips. Do I want one of these for my library socket? Yeah, something like that. Dip is what I'm looking for. Aha! Here we go. Yeah, I don't know the dimensions. Yeah, exactly. I want one of these. Because it's going to be through a hole into the PCB, and I'm going to plug the controller into that. But yeah, I guess here I need to find the actual dimensions of the damn thing. Okay, we'll find that. That would be here near the end, I think. So it's 0.7. What are the units? I wish people would say what their units are. If that's 0.7 inches in millimeters. What would it be? Guessing that that's inches. That doesn't sound right though. Do I bring out my calipers and measure it myself? Is that really 0.7 inches? I suppose it is. 0.7 inches in millimeters, please. 17.78. It doesn't match anything I have. No. It's probably this, right? So the thing is, I was off screen. I was looking at this pin count, right? They have 13 pins instead of 12, right? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's a 26 pin one. And DigiKey wasn't selling a 26 pin IC socket, but they were selling a 28. So I was thinking about getting a socket that has the 2 extra pins and just not using them. So I think this is what I want. Right? I'm guessing. But well, we'll just go for this for now. What's this one look? Oh, that's long pads. Huh. Let me just pick this one. Oh, we don't need to show it. I guess the footprint just has it. We'll move that down here. Okay, so then that's my symbol editor. Should be able to instantiate on the schematic now. There it is. And I'll put it there. And then go to the schematic, update from the schematic, annotated, and there's my socket. And I have no nets for all those pins yet. So put that right there. I mean, I think we're on the correct order of scale, right? Slightly narrower than the switch is. Actually, I don't think I got it correct. Well, no, hold on. That does work. That is on the order of the right size. Okay, there we go. Hey there, cat peasant. I'm stumbling through KiCad. You should just use a single socket if it's available. Yeah. So this will have 2 extra pins but we don't need them. I'll just leave them unpopulated and unrouted. What's the problem that it's telling me? Okay, no errors here. Was it on the schematic side it had an error? No? Oh no, there are 2 errors. Oh right, it says I don't have anything routed on the switch. So we'll just quiet that by saying that they are no connect. See, I know how to get rid of errors and warnings. Okay. Let's see what this looks like here. Hey, look at that. It's off the board though. I need to move the edge cut. Make our board slightly bigger. Okay, so we have the socket for the controller, and there's a switch next to it. All right, making progress. So what I was thinking was to have 6 switches to play with, because I don't want to make the full keyboard and solder all that junk. I just want to have like enough to have at least 2 rows and 2 columns. And what did I think of? I thought of adding, instead of 2 by 2, making it 2 by 3 for some reason. What was that? Oh, because I have enough parts for that, I think. Anyway, what's the thing? What's the shortcut to copy? Is it just C? Nope. Control C. But there's duplicate, Control D. That's what I want, right? I want everything there. Control D. Control D. There. Now we got all the switches we could ask for. And I need to, what's the key here? Right, fill in switches 1 through 6. You can also use a single row socket twice. Just place them according to the distance between rows that you got from the data sheet. Select 2 of the pins that are D plus D minus for the USB. You could use 24-pin socket and just not solder a pin on those. Oh, that's a good point, Sarian. Yeah. I wasn't planning to use those anyway, right? It's not shown on that one. It's shown on this one, though. These 2 that they added, right? So what would they would just hang off the end? Or I would just not solder pins to them? Problem is I've already soldered pins to them. As you can see, if I show you here, I've soldered all 26 pins on these. And these are the ones I was planning to use. I guess I could buy 2 more and just not solder pins there. What's the difference between 24 and 26 anyway, right? Let's update from schematic. Oh, it's just saying that there are no nets for all of those things, right? How are they oriented in this? 1, 2, 3, 4. Okay, they're kind of numbered weirdly. But I do that, and then I'll fix it on the 1, 2, 3, 4, 5, 6. I don't know, this is fun. This is not significant yet because I haven't done all the nets and stuff, but hey. Just trying to get a rough idea of what the board would look like. And if, oh, I know why I was going to have 6, because I need a TRS connector down here. That's right. So I guess the idea I had was to do something like this. And make a board of about this size. And put a TRS connector right here. Right? What's that 2X label on that mean? Oh, X as in not connected yet. Yeah. Okay. All right. I don't know if it matters, but I figure until until I'm going to get to the stage where I'm wiring this up, I'll just make the schematic look like the PCB. Okay, now are they going to have a symbol for an audio jack? Oh, they do. I want an audio jack 4, right? TRS. Without a ground. Exactly, I want this. Annotate. Okay. Edit that. Does it have a footprint? No, let's give it a footprint. Am I going to be lucky and is there going to be TRS in here or audio jack? Connector audio. Ooh, here we go. Not XLR. It's like a, was it 3mm? I might not have it. I might have to import it from DigiKey or something. Yeah, these aren't the right kinds of connectors. Definitely not XLR. Those are like that. This might be it, right? I just need, is it 3.5 and not 3? So it might be one of these. Yeah, like this. A footprint like that. That might be it. Let's just pick this for now. And okay, save that. Go to schematic, update from schematic, or go to the PCB, update from schematic. Oh, we got our jack. Okay, move over there. It would like sit over there, right? Grid to, I don't know, 1mm. It's not putting it. I know how to fix that. I guess I don't. I need to go to 0.5mm. There we go. I want to line it up. That's probably what it should look like, right? Ah, can't move it. There we go. So that's roughly the proto board I want to make. There are no other connectors on it. Oh, this needs to overhang. Yeah, this needs to like be more like this. Yeah. That means I got plenty of room for this audio jack. Anyway, that was what I was originally envisioning. I guess the next step would be to add all the pins and then try to wire it up. All right. I mean, it's almost 2 a.m. Maybe I should... Let me try to replicate what I have on the proto board, at least one key. Oh, I need to have I need to have room for a diode too. I guess we would put that... Where would I put the diodes for these keys? I could put them anywhere. I could put them down here, right? I wonder where they are on my corn keyboard. I'll have to take a look at that later. I don't want to look at it now. Let me just put one off to the side. So we're going to need a diode. I forget what diodes are which. Is it one of these that I'm using now? Sure. General purpose we want a switching one, right? I forget the number for the switching diode. One N 4148. Standard switching diode. No idea if this is what I want. Wait, what's the difference? That's surface mount? That's through hole. Alright, let's just add this. So, rotate. Let's move all these guys over. Beep, beep, beep. Beep, beep. Ah, don't add anyone, just drag it over. I need more room. Move over there. There we go. Okay, so how do I have this wired up now? Edit library symbol. I need some pins. It's going to be based off of this data sheet. So I'm using GPIOs 8 and 9 right now. 8 is wired to that one, so let's just use D8. Pin number. I mean, counting from here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Electrical type. Good question. I forget. Is that a column or a row? Back at the code. Beep beep. Close everything. Okay, so the columns, which are outputs. Okay, I'm going to wire the 8, 9, and 8, 9 is outputs, and 10. Okay, this is an output. Put that here, and D10 is right next to it, or D9 is right next to it, right? So can I just duplicate that? I can. Obviously gonna need to make this symbol bigger. That's okay, I'll fix it later. The 9, pin 13, also on output, okay. And then I'm also wiring D0 and 1, but I'm not going to worry about that right now. But it's on the other side, right? D10? Yeah. Okay, so another pin over here. D... Pin 14. I think I'm counting. It's been a while since I've learned how to count pins. But anyway, I think it's input. And flip it around. There. Save. Okay, and then that should have updated. Oh, it didn't update until I do update symbol from library. Now we got pins there. Okay, the way I have it wired is that is going, well, I need to get rid of the no connects. Cut. All right, wire from here to here, and then the other side goes through the diode. This way actually. Hitting the wrong keys. Beep beep. Eventually I hit the correct keys, you know? Rotate that guy. Okay. Yeah, I have him going back into the oh, I totally didn't do that correctly. Undo. Can I just delete that wire? Okay. This is actually going into that. And this is going into that. And this is going over to D8 right now. And if I wanted to add in the other button, I'd have another... Yeah, I'm going to need lots more room than I thought. Well, let's put in both switches. Why not? Whoops. So, duplicate that to there, and okay. Wire from there down to there, and wire from there up and over to there, and then that actually connects into the same row. So it's horrible. I guess it would make more sense to draw the diode like over here, I guess. Can I move this? How do I move? Select the node. Can I move it? Ugh. I don't want to do that. Abort. Okay, I need to get better at this. Okay. I didn't leave myself enough room. Not what I wanted to move the entire symbol. It's not moving the wires with it. Shouldn't it move the wires with it? Why is it not moving the wires with it? I guess it just doesn't. Oh well. Then I'll just leave it where it is. Delete. Getting there. I want to move this guy. Of course, the wires don't move with it. Guess I got some more YouTube videos to watch on how to draw this thing. Use net labels, you don't have to connect the wires everywhere then. But I need to practice. Having software try to move wires is a two-edged sword. I guess I just assumed it would just move it with me and move it for me. Yeah, and it drew a line right through that. I guess I'll just move it. Nope, not that one. Let's annotate things. These are roughly where they would need to go if I were to wire them up too. Yeah, it probably would be better just label the nets and not bother with wires, right? Have like rows and columns. Anyway, this is just to get started and get some practice with this. Is that how I have this thing wired up? D8 to that one, D9 to that one. Yes, I do have two diodes, and they are oriented where that side, the anode, the bar, is facing the switch because we're driving driving that, right? We're driving these low. This is pulled high. So we want the current to go from high to low and not back the other direction. So I think that the polarity is exactly like that. That's how I have it. Okay, so save that. Go to the PCB and update it. Okay, so now we got some diodes to place. Okay, and then we get to do some routing. Fun stuff. All right, so let's move this down a little bit. Rotate it. Aha. Rotate that. Wait a minute. Well, that's the same net. It has to go to both places. Okay, so I can put them like that, right? Yes, and then I can I wish I could, yeah. This is where I want to start drawing traces, right? So front copper, route track from here. Whoa. Yeah, it did that. Sure, we'll go through there and then around here and down to there. Whoops. Whoops. Can I undo that? Yes, I can. X. I want to avoid those weird angles though, right? What happens if I just go straight to it? I mean, we're on the back side. It doesn't really matter. I just want to keep away from these holes, right? Just keep it simple then. There. I routed one trace. Ha ha ha. Oh yeah, I said the word rat's nest, right? When I was watching the videos on PCB design and KiCad, that's what they call these lines, the rat's nest, because when you start and you have a complex design, it just looks like a bunch of lines everywhere, like a rat's nest of lines. And the goal is to just route these. So like, it wants me to place a trace between there, done. Place a trace between there and there, done, right? This one's going to be more difficult, right? I got to go around that hole. And then over. Let's do the same thing that I did for the other one, right? Like that. And oh, you can draw around those. That's kind of cool. How come it won't let me go further down? That's weird. I can go through there though? Why don't I just do that? There we go. And it wants to go around there. Why? Oh, because there's a trace in the way. Oh, interesting. Huh. Cool. Design rule check. line on the silk screen. Oh. Wait. There's a silk screen line there? Wait, run that again. Oh, that U1. Okay, let's move that one. Yeah. So that's the silk screen one? Oh, it is. So what's that one then? Is that fab? Yeah. So I kind of want... Whoops, I don't want that. Escape. Ah, it's moving the wrong thing. I just want to select that. Oh well, I got it off. I got it off the edge there. Now there's probably only 2 warnings. Okay. I guess that is a silk screen all the way out to there. So I guess to shut it up for now, I'll move this back. I don't think I have the right footprint for that. But I just want to see no warnings. There we go. No warnings. So that's roughly how I have it connected, but with those extra switches not connected yet. Hey there, here. Tim Bodette. How are you today? Or tonight? Or this morning? For you, it's the morning. For me, it's the middle of the night. I need to go to bed soon. Yeah, audio jack to connect the boards, like this corn keyboard. See that? A little audio jack. It's a TRRS, tip, ring, shroud, or whatever. So I'm just putting that down for now. I might move to USB-C instead. But before tonight, I had never really used this tool, but I'm designing the circuit board for a prototype keyboard with 6 keys on it. Sort of a step up from this... what do you call these? Solderless proto boards. So I'm going step-by-step process of making my own keyboard. How are you today? That's okay, Tinspin. I can't type either. I take it that Tim had to go on to something else. I hope, Tim, if you're still around, I hope you had a great stream. You stick with the audio cable. USB-C is so over-engineered. Thing with this audio cable is that you're not supposed to unplug it or plug it while you're plugged into power, because you could cause a short between ground and power. Now, I haven't drawn that yet, but I need to do that. I need to pick which pins are ground and power and data and route them to the correct pins. So the green and yellow here are my data lines, and then my black and red are my power lines, and so these 4 together are simulating my TRS between my 2 controllers here. So, but I'm not sure if I'm going to be able to stay awake long enough to do that part. But what you see here is sort of modeled over here in my schematic. I haven't wired up the other 4 switches, but I'm just trying to replicate what I have so far with my proto board, which is I have my controller, and I have 2 diodes and 2 I guess you call them push buttons, but they're really keys. You're around but getting off the keyboard soon? Stream is good, just up late because nap went wrong. Well, I hope you get back in sync. Glad you had a good stream. I guess I'll have to stream a little bit more since you rated me. Yeah, so I'm just kind of throwing this together. I've never used this CAD software before. This is KiCad, K-I-C-A-D. And just trying to replicate what I have on my proto board and then expand it to have 6 switches and the TRS jack and just see what I can do. I don't know if I have all the correct footprints, but the idea for this proto board is I'd have this dip socket that I'd take these already soldered pins, because I had to solder pins to these KB2040s to plug them into the solderless breadboard, and so I don't want to have to desolder that, and I'd hate to waste these controllers. So I'm thinking for the next level proto board, I'll have a socket that I just plug these into. And if you're really observant, you'll notice I have 28 pins while these only have 26. That's because I went looking at DigiKey and I couldn't find a 26 pin one. There was 24, 28. So I'm like, okay, I'll do 28, and then 2 of these won't be populated. Actually, I guess that means I have these wired wrong. I'll have to fix that. Yeah, let me fix that. Let's update the symbol here. Edit library symbol. I'm making my own symbol here. It's not pin 12 and pin 13 then, right? If all the way down we have... Actually, no, these pins are correct. It's that 14 will be unpopulated and this will be 16. That's the problem. This is actually pin 16. If I wanted to be really accurate about it, I would draw 2 more pins and I'd say label them not connect. Right? Let's move all these up a bit. I'm gonna need to redraw this rectangle, and I don't know how to... Oh, I guess I can drag the corner. Ooh, there we go. I can do that. So we can add pins for like the one on the end here. Actually, why bother? Why bother? I just won't have anything drawn there. Or I just won't have anything connected there. So 14 and 15 won't connect to anything. So, but then, so it goes 1 down to 14 and then 15. So 14 to 15 aren't going to be connected to anything. And then 16 is the next one. So let me save that. And then this I got to do update symbol from library. Close. And then I got to reconnect my... like that. Oh, and this wire needs to be moved slightly down. There we go. Hey there, Ramey. It's Artist Ramey. How are you today? So are these boards somewhat pin compatible with the Pico board? No, they're more compatible with the Pro Micro and Elite C. So supposedly the KB2040 and the Elite C have the same pinout. The same size, same pinout. Except for, I think Adafruit added 2 extra pins here, the D plus and minus. But these are all like the same, like the grounds, the reset 3.3 volt, MISO, MOSI, they're all the same place on the Pro Micro and the Elite C. Got back from bouldering. Wow. Impressive. Yeah, I'm just going first little baby steps towards doing the CAD design for the next prototype, the next level of prototyping for my keyboard. So let's make sure this is all correct. Right, so I didn't route these correct. So these need to be changed, right? So let's delete this. Not that. I want to select that trace. There we go. Cut that. Okay. Wire from there to there. Correct? Hold on. Yeah. It's this one that needs to move up one. Wait. Did I do this right? I don't think I did this right. The diodes have to connect. Yeah, this trace has been. This was wrong. Ooh. I need to select this and delete it. There was a way to select the entire thing, right? Show net, highlight net. Is that it? Yeah, see, it should go up to there, not there. What was the key to show the entire trace? I forget what it was. Right click maybe to show me. Properties. I don't know. All tracks in net? Aha, there we go. Then I can delete them all. Okay, if I need to go from there to there, I have this other trace in my way. I guess I'll have to go through a via. Yeah, I think that's what I'm going to do. So this will go to there and then via. Over to here. Look at that. We flipped to the front side copper. All right, and then this trace here was wrong, right? Okay, so this needs to go up to there. There we go. I kind of don't like that though, but it's on the back, so it's okay. Did pretty well, Raimi. These are through holes. They're already on the bottom too. Oh, yeah, you're right. I don't need a via there. You are right about that. Okay, so I don't need that via. Delete it. Select all. I don't want to select all. Oh, it was you. That's the key. Okay. So delete that, and then we'll just wire straight to there. There we go. So I can click that and hit... I can click that and hit U. Oh, cool. There we go. What's that K doing there, by the way? I don't know what that K means. Has something to do with the diode that I placed there. Anyway. Okay, so this is correct. I'm not going to connect these two down here to anything. These two are wired like the blue and green here. This red one is this actually coincidentally colored red there. And then those diodes are both plugged back into the two switches. Those are the correct sides. Yeah, all right. Run the DRC. No errors and no warnings. All right. Well, the good news is if I sent this off to a board house, at least for one of these, it would be equivalent to what I already have. I would just need to solder in the sockets on the back, and I'd be able to plug my switches right in, plug my controller in, and it would just work. I don't have the connection to the TRS yet. Can I work on that now? I guess so. So back to the schematic. I guess I need to add the pins for power and ground and data in, data out on this guy. So edit library symbol. All right, so new pin. Let's do ground first. I guess I'm using pin 26, 25, no, 28, 27, 26 is a power input. Actually, I don't know which is which. It would be power input, wouldn't it? Because... no, power output, because it's power is coming in from the USB and coming out of this chip. So this is ground. And then we have another power input, which is VCC 24. One through 20, no, 1 through 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I've got my numbers wrong. If it's 28 to a side, no, 28 total, 14 to a side, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 26. Okay. Should I call it 3.3V? Usually it's VCC, right? I don't know. Let's be consistent. 3.3V. Okay, and then I'm also using the GPIOs 0 and 1. So that's pins 2 and 3 for D0 and D1 as, oh, one's an input, one's an output. Yes, so D0 is the output, correct? Yeah. Pin 2. Output. I don't know what but Vado means. So just putting the diodes in the same orientation? Why? It was easier to route with them back to back because they share a common side. Why would I want to put them in the same orientation? This is D1, pin 3, input. I just realized that that one should be turned around. Or not turned around, but just moved out. Is that correct? I think it is. So save, edit, update from library. We got more pins. Okay, and then all right, and then I don't know which ones of these are which, but I guess I can just pick one. It seems logical to put power on the last one. I don't know why, or I don't know if it's correct, but that's what I'm going to do. So that would be the sheath, right? No, that doesn't. You should want the sheath to be the ground, right? That's going to be the last one connected. Why can't I just make it power? That's the safest, right? And I don't want it to connect there. How do I prevent that? Delete it? There we go, deleted. All right, wire ground through to, I want ground to go to hit first, right? I have a feeling I'm going to want to move the jack above these switches because otherwise they're... Let's just do that now. Now I regret drawing these things. That's okay. It's not too bad. All right. So wiring that to there and that to there. Okay, this is going to look odd. I think next time I work on this, I'll do named nets, and then I won't have to draw these wires going crazy directions. There we go. Just drawing something for the sake of drawing it somewhere. Save, go to the PCB, update from schematic. Okay, so we've got more rat's nest things. So let's wire them. Probably, hold on. Is it better to do this one first? Well, we can do that one, and then this one can go around the other way. Or on the back side, right? No, this is surface. This one's surface mount. I'm going to probably want a through-hole one instead of this. We can do that for now. And then this goes over to there, and this one goes over to there. Easy. Run DRC. I got a warning. Track has an unconnected end. Huh. Oh, look at that. There's a track there. How did that happen? Fixed. Run the DRC. No errors, no warnings. Great. Okay, so I would just print out 2 of these and wire them, and then connect the 2, and this would be equivalent to what I have now. Honestly, know nothing about coding or software engineering. Find my streams very interesting. Oh, thank you. Thank you, Ragatags. The rarely cited Rhymo. Yes. Hey there, I play Poker Belly. I'm doing good. I'm staying up too late though. I'm just having too much fun working with tools. I have no clue how to I have no clue how to do this properly. That's okay. Like, I know one thing I'm not doing correctly is I should have a copper pour, probably on both sides. Actually, maybe I don't really need one, right? Because these switches don't really need to have there's no common ground we need. All the electrically sensitive stuff is on this board, and it's already has its own ground plane. Yeah, I probably don't even need a copper pour at all for this circuit board, right? I can just have it exactly like this. Bought an Arduino kit that you've been playing with. Total noob at electronics. So, from my experience, when you're going to get into electronics, these solderless breadboards are like the easiest introduction. Well, the only thing easier than this might be those kits that you can buy where they have the individual components and you just push wires through a coil to connect them. But this would be like a step up from that. This is like adult level proto electronics. So you have these wires that you can just easily unplug and plug them back in. And so I have a diode plugged in right there. The most complicated thing about this is that to get this key to work, I had to solder a socket. Actually, I can show you what the socket looks like. On the back of this guy, see these black things? Those are the sockets for the key switches. So I had to get it to plug into this breadboard. I can actually show you this because it broke off earlier today. I soldered one of those pins, a pin to this to both ends of it, and see one of them broke off. But I soldered 2 pins of it, and then I can stick them into the solderless breadboard. But anyway, these are nice because for most things you don't have to do any solder stuff. You just push it in, and then all the rows are connected to each other internally to the thing. But then the next step up from one of these would be to do a printed circuit board or a proto board where you hand solder it. But these are so easy to do these days. Like this KiCad software, I just watched, I don't know, a week's worth of YouTube videos to get intro to them so that I know at least something about how to use them. And then I'm able to draw the schematic, get the PCB, look at the 3D model, and I could take the output of this program, send it to a board house, and pay him $20, and then a week later it arrives on my door, and all I need to do is actually get the components like these diodes, and like it's showing here, push them through and solder them on the other side, and cut the pins excess off, and I'm done. This is where I'm going to plug in these KB2040s. Here's where I'm going to push in the key switches. Easy peasy. Ship the Gerber to JCL, exactly. See what comes back? Hopefully, exactly what's shown in the 3D model. A power is actually provided by the KB2040 off of the USB. What I'm doing with these two traces here is I'm taking power and ground and exporting them to that audio jack so that you can then wire it to another one of these, and it would share the power and ground between the two boards. Oh, one thing I haven't thought of is I think I have to have the right side board swap these two traces, right? Because I can't connect the two transmits together. That won't work. I have to connect the transmit of one to the receive of the other. So this wiring is correct for the left-hand side, but not the right-hand side. So I guess the way I would do this is something like this, where I would I would duplicate this entire thing like this, and like this would be the left hand and this would be the right hand side. So they're annotated, and then what is this going to look like when I do this? Am I going to regret this? I know I pulled in a just exact duplicate of everything, right? Except it's not laid out the same way. Let's extend the cut, and I probably want to make it like a cut that goes here with a little thing where you can break the two boards off from each other, and then I have to wire the these two differently than I wired it over here in order to make it match correctly. But I'm not going to bother with that right now. We'll undo this. I think I've done enough for one day. Let me make sure that there are no errors. Actually, can I... When I did undo, it really does undo, right? So there should be no errors. Electrical rules check. No errors. Updates from schematic. I got warnings, no nets, right? Because I don't have any nets for them. The DRC has... Oh, there is an error. Wait, what? Do I have an extra trace? How did that happen? Unconnected. Okay, well, let's reconnect it. I wanted to route out here. There we go. How did that happen? Anyway, I think that's enough for one night. Completely reversible? No, not completely reversible. I think that would be even harder. Ethernet cable is the final cable. There are people who use RJ11 connectors. There are people who argue that there's no, like, it's sort of an abomination to use audio jacks for power. I don't know. I haven't settled on it. Part of me wants to change this to a USB-C. And because I only need to use it for, well, I'd use all four conductors on it. And it would just be nice to not use an audio cable, I guess. But yeah. I guess I'm going to leave it on this. Leave it on this screen while I find someone to raid. Look at that. Beautiful proto board. It's going to be a 2x3 keyboard. My favorite streamers who I would raid are not on tonight. Maybe I'm just up too late. Anyway, I hope you had fun watching. Probably stream tomorrow. And I'll do a little bit more refactoring and a little bit more PCB stuff. I'll probably try to make sure I have the dimensions correct for this socket. And then I need to get the correct footprint for my connector between the two boards. And yeah, wire in all the other 4 switches. Oh, did we ever find an answer to whether or not to orient these the same way? I think it makes sense to orient them back to back because there's this common trace between them. Hold on, did I wire that? Yeah, this common one that then goes up here. But I don't know, maybe it makes more sense to turn one of these around. I don't know, we'll get to that next time. I missed it. Okay, I'll go back and look at the chat. What did you say, Sarian? Because it's more consistent and it'll make it less likely to make a dumb mistake. The thing is, they're marked on the silk screen, right? So I don't think it would be too hard to mess up. The silk screen here has a little line that you match up with the actual diode there. So I don't think it'd be too bad. RJ14. Well, the RJ series are all similar, right? So any of them would do. I just need at least 4 conductors. So it doesn't matter too much. I might just go with TRS because I have that cable with my corn. I don't know. I haven't figured out yet. Heck, I could just use a ribbon cable, right? Just a 4 conductor ribbon cable between boards. That's another thing I could do. Doesn't need to be that fancy. What are those holes there for? Oh, those are like the alignment holes for that connector. Yeah, anyway, I'm prolonging the inevitable. Let me close things down. Save this. I need to figure out what do I need to check in here. Certainly not all this stuff, right? Okay, I did make some custom changes to these to get the 3D models working. So, do I check that into my local branch? Let me think about this. So, oh, do I need to restart VS Studio to see those other repositories? Hold on. I might need to restart VS Code to see that. And normally it would give me a repository pull down so I could look at these changes. What if I just open that file? And then hit the graph. No, that didn't work. Try again. Nope, it's showing me the wrong repository. It wouldn't be too bad to reload it. Reload. There it goes. There it goes. So now I have the repo thing. So that's the one I changed, right? No. Yes. So let me put this on a branch. I'll figure out what I want to, where I want to upload this to later. Check out. Beep 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 beep. What do I want to call it? Maybe I just keep it main. No, I want it to be different. I want main to be... No, let me think about this. If I pull... It's not going to be origin. It's going to be like upstream when I'm done with this. Upstream main can be different from my main, right? Yeah, yeah, so I can just keep it called main for now. So just commit. And this will be repair, well, fix 3, can't type, models for Kyle's switch. It's Kyle's sockets, right? Switch sockets. Use project local paths. Okay, I just don't have anywhere to push that yet. Wait, what did it... Oh, I'm in the wrong... Shoot, I'm in the wrong directory. Beep beep. Let's repeat that. Let me get the commit I just accidentally made. Grab that. Go back to here. I need to go... Yeah. To PCB. This one. Serves me right for not doing kit status first. Paste. Save. There. Alright, and then, yeah. 2 levels up. Okay. I don't think I need to check cache files in, right? Okay, we do need to mark that one as updated. Actually, no, these go with my... These I need, right? Actually, I don't know. I don't know if I check these in or not. I think I do need to check these in. What about these zip? No, these I don't need. So I want to get rid of... I want to ignore PCB backups. So let me go into my git ignore and do / PCB backups. And then going back to here, these should all vanish, right? Yep. Cool. I think I want to add all of that in. All right, so let me commit and amend. This is not what we did. So add PCB. That's basically what it did. I can push that for sure, right? Can push that one. I just don't have a remote yet for the key switch KiCad library. One suggestion for the diode location on the underside near the switch. It's a good idea. Well, I don't think I had plenty of space on this board, right? But on the real keyboard, I won't have as much space. In fact, I won't have any on the front side. It'll get in the way of the action of the movement. I just had extra space to put them here, but you're right. On the real keyboard, we'll want to try to put them on the back side. All right, so we had space to put them here, but yeah, you're right. I could put them like right here, right? Could put them with each switch. I could have the diode sitting nearby. Yeah, and we could still go through a hole, and we would just cut the end off, and it wouldn't get in the way of the switch. I would just put them in outside of the silk. The silk screen is showing the keep out area, I guess. So I'd just put the diode here, and here, and here, 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 and here. You know what I can do when I ship this off to be made? I can have a version, I can have on one plate of this one with the diodes here and another one with the diodes under the switches, and we can try both. Actually, that's not true, Tinspin. I found a keyboard that doesn't use diodes because they have enough GPIOs to direct wire every switch to a different GPIO. It's called the Pinchy keyboard. It was under this one. This keyboard has direct wiring for each key goes to a different GPIO, so there's no diodes on this at all. It's just key switches. I don't even think they have LEDs, so it's a really simple layout. Yeah, because the Raspberry Pi Pico has like twice as many GPIOs. It's got an absurd number of them. Anyway, in 5.5 hours, I have everything checked in. I think it's time to say goodnight. Yeah, 30 is plenty for when you only have 18 keys. 30's more than you need. Cool. Anyway, I'll be back tomorrow. Have a good night, everybody. I'm not going to rate anybody. I'm just going to hit the off button. So have a good day. Thank you for watching. Bye.